So I'm going to try to fix a memory leak issue that I'm getting there from the icon sidebar. I'm probably not gonna be able to do anything. Just not really sure because I didn't think about any solutions before the last time that I was trying to figure out yesterday. So I don't expect to be able to do much. But I'm gonna try to think about solutions. It's kind of annoying me that it is it seems like more complicated than it should be, but I'm not really sure how I can change this. So like last thing that I tried last time was to move so I'm probably going to change instead of doing well, I'm still not really sure if I'm going to continue to make the icon names based on the folder on the like this folder here on the project. I think that's probably not very good, but it's the easiest approach, I think. So the main thing that I changed from last time. Oh, actually, I'm still not putting yet. Yeah, so I was gonna do this, just basically use this get theme icon, and I decided to use this file system icon, which is already is an icon that already I think this is incorrect. An icon that already puts on the default theme. That's because of the caps lock. Yeah, oh, actually, is this? It is correct there. So what I plan on doing, I couldn't put this inside of the constructor because it complains that in order to use get theme icon, we have to use on this notification here. So what I'm planning on doing is looping over. And now that I think about it, I'm not really sure. And maybe I should move the loop that I have here instead of here. But instead of loading the icon from the using resource loader, which is the function that was getting a problem, I also think it's just easier to think about if I load the icons from the thing instead of the folder. Which means I should probably change this. Like the most annoying thing, which is a fundamental problem that I go back to all the time, which is a problem that I assume that I'm gonna have because the way that Godot was designed. So like there is one thing the main thing that I can do would be like change the way that the caching works. So if I could find maybe, I'm not really sure if that would solve or not, but like the fundamental problem is that Godot is designed with an object-oriented paradigm. And based on the way that the classes are structured, like because I'm building the scene from C++ codes and then I'm going to load the scene at a different runtime, when the moment I build the nodes, I'm not gonna have the information. So like the only information that I'm gonna retain is the information that I'm able to save using this resource saver function. And this basically saves the nodes that have the owner set to the node you pass through here. So you call this function from the package scene. The package scene is a class that they created to serve as this like abstraction that holds the scene state. So when you call back, I still haven't studied this function, like the source code, but I know that it's just gonna it's gonna build a scene from the root node you pass here. So any node that is a child of this node that has the owner set to it is going to be saved. It's going to be cached on the scene file. And if you don't set the owner, then it's just not saved. So the nodes that are reconstructed and don't have owners are the nodes that are initialized inside of other nodes that have the owner as the root. So the problem here, the fundamental problem is that in order to create anything on the classes that are gonna maintain themselves, I have to put them either inside of the constructor or I have to make them as a variable. And if I make them as a variable, the problem is that the way that Godot translates the information is by using the variant class. So variant class is a class that uses C++ and uses operator overloading to serialize the information. So to change, translate types basically. So they created a bunch of structs and a bunch of helper functions and stuff like that, and this variant class, which allows you to translate from string, for example, to a vector or something like that. Like any class that you have on the variant, you're able to save. So I think that the variant class does have vector. It has, I think, I don't remember. I think it has vector of string names and vector of variants. And the reason why it has to be variant because you use the macro inside of the class to subscribe the property on the class. So whatever is going to show in the editor is going to be what you put on the class using that property. Basically, everything you're going to put on the bind methods, the bind method is going to be like serializing the function information. And I don't remember exactly how it does that, but it has to do with the variant as well, I think. So it has to be with it has to do with the class DB, which is the class that they use to manage the types, with the method bind, which is I think is method bind, and variations of method bind, which is the class that they use to hold the information of the function. And I think it has to do with the variant also, but I don't remember. But this one is basically for serializing the functions of the class. Then use that property to serialize the properties, and use the add signal to serialize the signals. So anything that you register with add property, you're going to be able to change on the editor. But the problem is you have to use a variant. On add property, I'm 100% sure you need to use a variant. So you need to specify the type as one of the types that the variant supports. So that means that if I want to cache the information as a variable on the IconSideBar, I have to use a data structure that the variant supports. And I think I was gonna do vector of strings, or vector of string names, but I couldn't find an example of that property that uses vector of string names. It just has vector true and stuff like that. So one potential way would be to use a vector of variance, which I think I did on a class that I did to try to serialize signals, which I realized later on that's not necessary. But the problem with that is not very good because it's kind of annoying to, like, it's not very clear when you use vector of variance what the variance is supposed to be. And the reason why I was thinking about this is because I was thinking about passing the vector with the string names of the classes that I want to represent the icon. And then inside of the loop, I would, instead of looping over the folder, I would loop over the vector, and then I would just pass the string names as the values, and then I would be able to use that instead of getting the name of the files. I still think that's better, but I'm trying to think about like what is the best and most clear way to save the information on the class. And at what points, the other annoying parts that the cycles, like some of the stuff that, one example would be this stuff, you're only able to do a certain parts of the cycle. Like this stuff here, the stuff that I was doing before the loop that I changed to here, which is basically these things here. I have to do, like, it's better to do on the notification ready because I have to find the target doc that I'm gonna put the elements based on the root node. And then I'm only gonna be able to be sure that the root node is initialized on the notification ready, I think. I think you also could do on the notification the enter tree, but the ready is probably better. And both of them are going to be better than doing on the constructor, I think. So I'm getting the owner here, and then I'm using the owner to search for the... this is another thing that now that I think about it, maybe I should change this. I think, yeah. So like this is something that I changed on the nodes class, because I had to create a different function, which is add child external, because of the node thing. I didn't want to create another class to set the nodes as owners, and it's kind of annoying to remember to do it on the thing here. So I basically create another function on the node class, which is add child external, and then I just call add child later, and I just set external for the node that I'm. This is for when like later on when I was traversing the tree to save the scene. I created this other variable on the node class to be able to not to do breadth first search, but don't include the nodes that are built inside of constructors of other nodes on the scene, because I was looping twice to save. It's whatever. But here also I did this stuff to find the owner instead, and maybe I should do that on the other class, because the get owner, I'm not really sure if it's gonna get the, but maybe it does get the roots right away. Because here I'm just to make sure that I'm gonna set the owner as the scene root. I get the parent, and then I just traverse up the tree until I find till that there isn't a parents anymore, and then I set the owner as the roots. But I think that's maybe the get owner already does that, because I can assume that when this node is added, it's already included on the tree. Yeah. So yeah, for the identification tree to run, it has to be included, and I'm going to include it using the add child external. So the moment I add is gonna be an owner already. The owner is gonna be the root node already, I think. It has to be because it was working before. So I think the last thing that I did as well is to. So the problem is when I run. So this is another thing that I did. I'm running. I changed the way that the flow works on the setup. So the basic way that it works, and this is something that I really like about Godot, because I think it's very simple. So I think I really like the way that they structure this. Like the object-oriented parts is kind of bad because of object-oriented, I think. It's just more like it becomes more complicated because of the times, but I think it's just something more complex that is very hard to solve, and is also a byproduct of the language, which is C++. But yeah, the way that they structure the core of the way that the engine works is very good, I think. It's basically very simple. It runs the setup function first, main setup, then it runs the main start, and then it runs the main iteration. So the iteration is the game loop, and on the setup is gonna parse the command line arguments that you pass when you're executing the engine. This is another thing that I'm gonna have to think about, because I was thinking about on VS Code you can put the command line there. Like you can open the command line on a random place. Let me find some random directory. So I can click here. This is the URL of the file explorer. Can type commands, then it opens the command line, and then you can do this. You can do code and then the dots, which is the path of the current directory. And obviously, I assume you can pass any path you want here. And code is going to be the name of the executable, which runs the VS Code, which you put on the path, because the command line is like it works in the same way that any other program works. And this is something that I struggled a lot in the beginning as well to understand. But it basically works like any other program. So whatever, if you put a path to an executable on the environment variables, like this is basically the bridge between the like user and the operational system. That's how I think about it. So if you put the environment variables are the variables that the command line is going to be aware of. So any path you put on the environment variables that has executables, you're going to be able to use the name of that executable to execute stuff. So it's basically going to run the program that you have. So this runs the code executable, the VS Code executable, and it passes the current path as a command line argument to that executable. So you can think about this as being this path that it passes here is going to be the argv on the main function that all C++ programs are going to have, and all the other languages are going to have as well, even if it's not explicit, because they come from C. So there are gonna be variations, but I think all of them are gonna have an entry point. Python is a little bit different because Python allows you to, but it's still the same thing, but they allow you to pretend that the main entry point is any file, and that's the reason why a lot of the times you're gonna see if main if name equals main on the end of the file, because it's gonna treat the name of the file as main whenever is the file is working like the entry point. But at the end of the day, it's gonna be the same thing. So I think under the hood is gonna have the function that has the inputs, which are the command lines, and the functions. I don't remember. I think it's on the Windows OS or something like that. Yeah, but basically, I changed that function. And the thing that the reason why I'm gonna have to think about this is because I also wanna do because it's I do this a lot. It's a lot easier to do this than just to find the directory there. So it would be nice to create a executable that would do the same. But what I was thinking is that's gonna be kind of annoying because like the command line arguments that the Godot accepts are already. So like the way that you do it is I think is just change the. But this is kind of the problem. Like if you change the way that they parse the arguments, you're gonna change for all the projects because the final project that you have on Godot is just the engine compiled, so it's the same code that runs. It's just a different, like you can do optimization to remove the editor and other code that is not necessary for a project, but the core is gonna be the same, which is the engine. And the way that it's gonna work is based on the project settings. So the project settings is gonna, if you embed the data of the project with the executable, then it's gonna manually write the bytes to the final executable of the data and the resources, and then the project settings is gonna get the information from that executable. And if we didn't do that, then it's gonna get from the data file. But the way that it parses the arguments are gonna be the same, I think. So if I want to do something like this, what I'm gonna have to do is probably change, but maybe I can use project settings actually, now that I think about it. I can use project settings and then like maybe like check to see. Actually I can find the way that they use. I think that they use the OS class to find the arguments. I'm gonna look for the setup function. It's gonna be inside of this, I think. I just print. So they use the OS class to parse the arguments. So I guess I can use the same class, and then so here they're using this as a list, and they get from these args. These are gonna be basically the args you pass through the main line here. And all that I did was change the control flow so that I set a flag variable that indicates that I'm running the Cortex, and then I don't need to, I just put another thing on the loop inside of the loop that checks to see if this is Cortex, the Cortex flag variable is set. And if it is, then it runs my entry point function there instead of running the engine and then just exits the main loop. So like the reason why all of this is related is because when I run the way that I'm running here, which is the entry point function that I have inside of the loop, and then I create the thing offline, let's say, like not in the same runtime that the application or the editor are gonna run on. Like I'm basically using the sync cache to translate the state. Because of that, it creates this massive problem of how to capture the information, because that's like gonna directly impact the design of the classes, because it's gonna force me to put the information inside of I'm gonna have to encapsulate the information inside of the class somehow, and then I'm bounded by the variant types. And this is something that I learned with Haskell as well. So like the variant type is just a product type, and the product type in Haskell is like a tuple. So is basically a class that's gets the intersection of all the other classes. So let's say you have a, it's kind of like you're encapsulating classes together. So you can have like a string, integer, float, for example, and you put all in the same class, let's say. And this allows you, it allows the class to figure out what type you are using by like traversing inside of the class. It's like the class keeps a memory of what a float is or what a integer is and what a string is. And then once you pass a string to that class, because it can handle, it has all of the other subclasses on inside of its set, is able to navigate and then find, okay, this is a string, this is an integer, and so on. I think the variant works in the same way. There's a class that has a bunch of different types inside of it, which are like basically a product type. And I think that this is the issue because I'm bounded by the variant class. And I think that the other way, like if everything was running at the same runtime, I think that the difference would be that it wouldn't matter. Like I could save things on a hash map, for example. A hash map is not part of the variant, and it doesn't cache. And I think the reason why is because it's more complicated to make the hash map, to cache the hash map. So they decided to not put it, which is understandable. But I could use the hash map if I was running the same runtime, and then I didn't have to put the variable as a property of the class and expose to the editor. So, and it would also allow me to to loop over the variable uh, from the constructor instead of looping over from the property. Because the way that I'm gonna have to do now, I think, is like pass the variable to the constructor, like figure out or use a type that the variant accepts, pass the variable to the constructor of the class, update the value of the variable in the class on the constructor, and then later use the property as the thing that is going to I'm going to use to loop over to create the icons based on the names of the properties. But then I can use I have to use a vector of variance, which is not very good because it's not very descriptive. And I think if you use vector of string names or something like that, then the compiler complains. Yeah, so I guess I can just use this stuff here, and I can check to see if there is a path. Like if a path was passed, I basically use the same thing that they're doing here. Just copy this code, and then I basically copy the way that they're doing. And then on my project, let's say, and then I set or like I change some class or something. The thing is how, yeah, I think that the only thing that would change is like changing the state of the classes based on the path. So I would change the file system, I think, mainly the file system, and then whatever else I'm gonna do. Yeah, so actually I think that's not gonna be that hard now that I think about it. Because initially I was thinking I might have to just change the main loop, and then it's gonna affect all the projects on the path, and it's gonna be annoying. But I think that's not gonna be. Yeah, so the problem here is that I'm is leaking memory, so I'm not really sure what to do about it. Um, and usually this happens is when you don't. Oh, so I guess the last thing that I thought about doing is to delete this stuff here. Actually, and now it's not doing anything because I commented out. So I'm going to uncomment the class there. Then I'm gonna run again to see if it's like there's a bunch of messages showing up because it's probably not deleting. I'm not deleting oh yeah, forgot to remove that property. I was gonna look into the bind methods again as well. So, yeah, it does use, no, it's using the, yeah, this one is more confusing, I think. So it uses templates to, but I think that in some of these functions you're gonna use, so like this is the main class that they use to hold the information of the thing. And if I remember correctly, they hold on a hash map, the name of the function, the first name you pass there to a function pointer, I think. And it has to do with the templates. There is some confusing stuff with the templates that's it's kind of hard to understand. But it's basically going to be whatever name you put there is going to map that to the function pointer you pass as the second argument. As the second argument is the method, I think, and the first one is it uses a macro, which is another kind of weird thing that doesn't seems that it doesn't do anything. Like it just I think it like probably concatenates all the strings you pass together. I'm not really sure. And then some through some weird type stuff on C++, they're able to capture the arguments on the name, I think. So the second argument is the function pointer. The first argument is the name of the function, name of the arguments. Which would be this thing here. So it's passing the function pointer to this create methods. And then it's going to initialize the this class inherits from method bind. And this is the class that is going to hold the information. And I think on the constructor, yeah, this part is the one of the parts that is confusing. I think when I was trying to solve the static string problem, that's when I had to spend time. Like I think I used ChatGPT as well, but I don't remember very well how it works. It's very confusing. But I think it's just changing the pointer type, the function pointer, and I think it has to do because of the types of the arguments or something like that. And it's gonna save the function pointer here based on the constructor, yeah. And then generates the arguments based on the template. Like this is just spreading. It's like the spread operator in JavaScript. It just cancels all the arguments you pass there, which are gonna be passed as string names. I think later on the other functions, the way that is gonna parse is based on the string names. And here uses the parent and uses other stuff to translate, I think. And so this function is gonna parse the arguments and it's gonna use the parent class to translate the types. I definitely think that this is a byproduct of C++, because I think that's if this was done in Haskell, it would probably be a lot simpler. 'Cause I think that's probably Haskell's strength is dealing with the like this like dynamic types or templated types. Yeah, the thing that I was contemplating is whether or not to like to couple the classes, but I think that if I not couple the nodes together, but if I did that, then I would have to change the layout. Like the way that I'm doing now, The problem is like I'm not really sure how it's going to evolve. So the way that I'm doing is like keeping the component that shows the file system separate than the icon sidebar. And the reason why I'm doing this is because later on I might want to create the docs thing, and the docs would allow me to move any doc to any place on the scene. And another thing that I could do is just change the name of the nodes. So I could have some functionality that changes the name of the node. And when I do that, then it would change the doc that this icon sidebar is going to change, which is the thing that changes the whatever shows here. It's basically the same functionality that I'm doing, where I'm just hiding the element, and then I'm showing the element that I select with the icon. But this makes it annoying, I think, to do, because it forces me to put the if I was coupling them into the same thing, then I could initialize the class that is going to contain the state here on the constructor of this class. And then I wouldn't have to do everything on the ready. I could do it on the constructor. And I also wouldn't have to do these annoying calls here and then check to see if the class exists. And also get the owner here. And you'll probably make it a lot easier, I think. But the downside is that you lose flexibility. So now I'm gonna run, and it's probably gonna show there's a bunch of messages. Actually, there was way more before. Not sure what's happened. But I don't understand why this is happening. Because it's supposed to automatically delete the memory for the things that are parts of the scene. Actually, it might be because of the. But I think I comment this out, I think, because of the memory leak thing. I'm gonna try to uncomment this. But I think the first thing that I was thinking about, so I was getting a problem as I was tapping into on this thing here. I think was trying to delete something that either like it was crashing here. I'm not really sure why. When I was tapping over with the debugger. So I was thinking about instead of using mem delete, I could use q free or free q. I forgot the exact name. But the difference is that one of them is going to put the thing on the queue that's gonna delete later on the item, and the other one deletes here. And I think that might change the thing there because I'm not really sure if it's trying to delete twice. Because it does seems that it does have the object, but it's something else that is another error that happens when you try to delete. So I'm not really sure what's going on. And it's weird because the objects here are supposed to be on the scene as well. I'm adding all of them. And the reason why I moved this to the notification ready is because of this part here. So I was doing this before and I decided it's just gonna be easier, but now that I think about it, I might have to move the loop through here because that's gonna make it easier. Actually, it's the only way. Not the only way, actually, because I can loop again here. I can loop over because I'm caching. I'm gonna go over this the way that this works. So let me run this first. Yeah, so because it's not showing the other messages there, I know that's something is fucked up there. And it's interesting that is saying child is no here. I don't think I was getting this message before. So the way that this works is, so this is the part that I moved through this spot here. So like this is supposed to be the control element that is gonna be whatever name whatever I want to put there. So it's based on the string here. So whatever node on the scene I put this name, I'm going to use the roots to find that node, which is basically this, and then I'm saving that on this class as a pointer. So I have a pointer to that node. Then I cast that to control, so I can so I can set the minimum or get the minimum size. I was using this because of the scroll container, but I think that's probably not necessary anymore, so I might delete this. And then I add as a child, add the scroll container as a child of this target. And the reason why is because I don't know what is going to be the dimensions of the stuff that I want to put on the dock. So I want to be able to have the scroll on the elements. And this is the reason why. So I'm going to put all the elements that are created by the icons as children of the content scroll container. And then here I'm basically looping over. I open the file, the folder that is supposed to have the icons with the names. So the name of the icon is going to be the same name of the class that I want the icon to represent. And it's going to be on the folder of the project. Then I basically get the path and I loop over that folder, and I look for the files that have .svg. Then I get the name. And this is the part that I think I'm going to change as well, because I think it's probably better. Yeah, it's better. I think it's better to do it based on a variable, but then it gets into the whole property thing that I was talking about before. But then I set the name of the button with the name of the file, because I'm gonna use this later on the event there that I have to show the item when you click on it. It's basically this callback function here, and I bind the index of the button to send as an argument to this function, because that way I can loop over and can filter this the icon buttons, which is the vector that has the control nodes to see which button was selected. And I'm pushing this with a margin to the icons box. Then this stuff is going to use the class DB to instantiate the class based on the name of the icon. So the name of the file has to be the same name of the class, because I'm going to be using this function to create the object. And then I cast this to a node, and then I save this into this dictionary for later. I think for the same callback function there. And this is the part that I was doing separately before, but now I'm doing here. Just get this node and add as a child of the content scroll container. So I'm basically adding everything. And I was doing before is to hide all of them, but then it was complaining that I was trying to hide something that wasn't on the tree yet, even though I was doing like here, I think. And the reason why I'm hiding all of them is because I only want to show the first one in the beginning. So this is something that I was gonna fix after I solved this other problem here. Because if I add all of them and I don't hide any of them, then the layout's gonna be messed up. So I have to put everything as a child of this, then hide all of them except the one that's gonna show first, which is the first one, which I could do either before here, based on the index maybe, or I can do here as well, or I could do later. So the problem that I'm getting here is probably gonna be memory thing on because of the icon, deleting the elements on the icon buttons. Yeah, so basically I've been doing like this. So this is gonna be the last part where it breaks the code, and then you can look into the stack here. You just go back to the until we get to the last place. Yeah, so it is because of this. So I assume that what is happening is trying to delete something that doesn't exist anymore. But this is the thing that is weird. I think that this one makes sense. It makes more sense than the other one. Actually, both of them make sense. That's like they both have to be deleted because they're both parts of the thing. I'm just pushing the pointer to the vectors and not the actual thing, so it doesn't do a copy. It just is the same pointer. So it should be deleted by Godot on this when it's cleaning up the sync tree. But then the weird thing is that why is it leaking? Like what is it leaking on the end there? And it's weird because it wasn't doing that before, and it wasn't also doing this stuff that I'm doing here now. Maybe I'm not adding the contents, scroll content as a child. Oh, no, I am. Yeah, I'm adding as a child as well. But this might be. Yeah, so I think I should put an else statement here, but I think like it doesn't matter. It's probably not the issue there because I do think that's, but it might be actually. But it's just better to put this anyway, and then we just delete the contents scroll container. So I'm put another one here. I do think I have a message. I had a message there somewhere. Maybe deleted the message, but I was pretty sure that I had a message that checked to see if there was a node with that name. So maybe this thing here. That's whatever. Just gonna put that track again. I don't think that this is the issue that I'm having there though, but I think it's probably better to put this. Because the issue here is that obviously if that the condition doesn't work there, this node's still gonna exist, but it's not gonna be removed because it's not a part of the sync tree. Here I don't have to delete later because I'm adding the node as parts of the tree here. I mean, maybe I should copy this stuff though. Let's see if I can do it with the ass thing. Yeah, so imagine that. I'm just gonna leave it as a string because I don't wanna bother with this. And just search for the string on the code. If I see this message, then I'm gonna remember. I guess it was just a warning, but like it's probably better to remove the thing. I guess you can use it like this. You have to use this v format function if you wanna format the string before passing to this warn print. So probably the best way to do this is to use. It's kind of annoying that you have to use the getting icon on this part of the cycle. Maybe it's better that way though. But I think that probably what I have to do is move the loop. So I have to, instead of doing the loop here based on the folder, I have to do it based on a data structure that gets set based on the constructor. This is another issue. I think that's the reason why I decided to do it based on the folder. This is exactly. But what is annoying me is it's not this time. Is that I know that this is gonna be something that is gonna come up all the time. So, but it's kind of hard to think about a way to like solve this. Maybe should try like spend some time trying to figure out how to. This is a lot more though. How to change the caching system, like the sync file thing. Not really sure if that would solve anything. Like it's mainly gonna come up when I need to set the states outside of the class. I think it's exactly the same problem. Maybe I should try to implement a monad somehow. Because it's exactly the same problem. That's interesting. So like in Haskell, because Haskell doesn't have like everything is immutable and you don't have side effects. When that's the case, it becomes very hard to deal with state, I think. I'm not sure if I'm confusing the two things, but I think that it is related. So like in order to get around that, they have the concept of the monad. And a monad, you can think about it as a function structure that is going to allow you to capture states, as far as I understand. So like it works in the same way as a bind works, where it like yeah, it allows you to bind two different functions together, let's say. The most confusing part to me so far is because of the types, in the way that it's something more fundamental that has to do with the way the types work. Like it's the difference between type constructor and value constructor that is very confusing to me from a fundamental perspective. But I think it's basically the same. It's very similar. Like the core of the issue is that whenever you have something outside of the function, outside of the class that you want to say, you want to cache the sing file, there isn't a easy way to cache the states, I think. So all the information is going to be lost because you can't capture on the sing file. I think one way would be obviously to like use function pointers, but even then, like you don't have access to the memory. But I'm not pretty sure if monads would do anything. Because a monad's more to translate types from a structure to another type on the same structure. I think that's the purpose. I think the simplest explanation is like a flat map. But I think the principle behind it might be similar. Like this idea of capturing the state of functions. Yeah, I think that's probably the fundamental principle behind it. I'm not sure if monads are like the purpose is the same or if something different. I think the question that I have is what is the best way to capture function states? What is the best way to cache side effects? I think that's the thing. So the thing I was gonna try is this. I don't think it's gonna work either. I'm kind of out of ideas. This queue free. Oh. So now is a lot less. Hmm. So maybe if I do queue free on the other one as well. But I think I need to think about a way to change the whole thing, because it's not very good to do this, I think. That's probably the reason why I don't like it very much, is because I rely on this. Ideally, I should, and I think that this is a consequence of the whole thing. Like, it's the same fundamental problem. Like, because I can cache the state on the whatever, like from outside of the class, because it's not gonna be put on the sim file. It's gonna the consequence is gonna be that I'm gonna have to structure the class in a way that I can capture. But maybe not in this situation, because I think that regardless of the thing, I would have to do. Well, this is more because I want to maintain flexibility on the other class, which is not quite the same thing. Still the same. Let me use Q3 on this one, because it seems that it has, so it has a style box. So style, I don't think it has, it can't be the theme. I'm gonna try to uncomment everything and just do Q3 instead of the mem deletes. As I comment everything because they were giving an issue there. I'm just gonna do Q3. But even if it solves, I have to think about like the fundamental thing. Like, so how should it, even more important than how to redesign the class is this idea of like, should I try to cache side effects or do something different? Yeah, but I think that is like, it's kind of an impossible thing to cache unless you use like, I think that the only solution I can think is like overly complicated stuff, like using templates and then writing the string of the function, then parsing the string later. It's like just overly complicated. And like because the question is, I don't think there is an easy way to do this. Because like if you think about it, what I would have to do is after initializing the class, like or when I initialize the class, let's say I don't want to make it based on the property of the class. So I want to make the icons that are going to show up there based on a vector of string names, but I don't want to save the string names as a property of the class. I just want to make it based on the whatever I pass to the, so basically dependency injection. Whatever you pass to the class, then I loop over them and I make the initial icons like that. The question would be like, how do you capture that on the sim file? And I think it's just like too complex. There isn't any way to do this, like any easy way to do this. Because if you capture the data structure that you're using, then you're still gonna have to associate with the class, and then it's basically the same as saving as a property. As another approach would be to extend the variant class. And I tried to do that with different types, and I know it's gonna be very annoying. Because like they did a bunch of different structs in a bunch of different places, and there's a bunch of different functions. So basically, if you want to add a new type, you have to do like all of those things again and then debug them. Okay, like whenever stuff goes wrong, and it's gonna go wrong because you have to do one by one. So it's very annoying actually. But like the ones that they did already, like they encapsulates like probably almost everything, because either it's gonna be the types that they have there, or it's gonna be something that derives from an object. So like I could do vector variants and then save on the as a property, or a dictionary as well. The dictionary is another one that you can use, which works basically similar to the way the hash map would work, but is different under the hood. But like on the concept level, it's basically the same thing. Nice. So it's working now. Interesting. So the problem was one of these classes. I think the reason why it wasn't working when I deleted. Actually, I'm not really sure. Yeah, maybe it's some weird thing. So I'm gonna spend some time thinking about like what is the best thing to do after this. It was, yeah, I think it's always like this. Like there's always this war between, and it's very hard to find. And I think like everyone's gonna struggle with this because just the like property of the universe, and it's always relative to the observer. But there's always the range, which is like computation itself as well. So like the hierarchy of your values is going to determine the structure of your goals because they're a direct consequence of that. Everything's going to take time to do. Some things take more time than others, and it's directly correlated with computation because that's basically how you search problems. You solve problems, which is basically searching computational. Not sure if searching computational space is the right way to put it. But you're basically searching a solution. I guess you could say it that way. If you think that all possible solutions are on the space of computation, when you're solving a problem, you're searching for where that computation is. And the way you determine which problems to solve is going to be directly correlated with your values because it's going to be the calculation of how long it's going to take and how important that goal is and how that goal is going to impact everything else. So the reason why I'm saying this is because now I'm not really sure. It's kind of hard to calculate what is the best path to go because the fundamental goal takes more time, and I'm not really sure if it's even possible to solve. But like if it is the case that there isn't any obvious or simple way to solve their goal, what I could do is change the whole structure of the way that I'm doing things as well, which could be like one of the things because. Or I could change the way that the whole engine works, but I think that's too much work. So basically, there's the path of the fundamental principle, which is how to, like, what is the best way to capture side effects or to decouple how data changes the classes, or not to decouple how to cache without having to change the structure of the class itself. I guess with signals is going to be I can use the cache that they provide on the signal. So maybe that's not that big of a deal. And maybe it's a different problem that I have with this class. Maybe the problem is not that. Actually, it is. There's two different problems. One is the content. Is finding the. Is more a problem of flexibility. This one of the doc. It's like if I want to retain the flexibility, then it becomes more annoying to set up the node because I need to keep a reference to the node. Like this stuff here, the fact that I have to do this and to make it work, like that's the thing that is making me like I don't know, it just doesn't feel right to do like this. It makes me think that I'm probably doing something fundamentally wrong because it should be simpler than this. And then the issue is that if you let this stuff compound, then it becomes more and more garbage. So I want to be careful to not like do this, but at the same time, there's other problems to solve. So like the other problem is going to be very hard as well, the optimizing the editor file system. So I'm not really sure which way is the best way to go now. And I think that the reason why I have to do this stuff is because of the thing that I was talking about. That's like because the nature of the way that the cache works forces me to use this approach where I have to loop over the directory. Then I have to create this other class. But I guess it's different issues. Like they're both kind of connected, but they are different. This one is more about the structure that I use to compare, to match the what icons are going to be created based on the name. Because now I'm going to change the way that I'm loading them, which I do think is better. So I'm probably going to I'm going to move the loop to here and use these icons. So what I'm going to do for the other icons that I don't have on the defaults, I'm going to just add them to the default theme and then just do it based on a variable. So like I'm going to loop and then let's say I'm going to use this variable here, icon name. I will just put the icon name as a variable on here, and then I just put on the same kind of like namespace for the theme. Then each class that I add, I just make the icon as the name of the class, and then I add that to the default theme, and then I can use the function. I can replace the variable there here, for example. That's basically what I'm gonna do. And because I'm gonna do this, instead of looping over the directories, I could loop over the vector because it's much better. Then I don't have to create this folder for each project, which is much better. I can just set from the sync function. And this is related to the fundamental issue that I have here, because there is it forces me to change the structure of the class, which makes the class more complicated, which becomes more annoying to solve. Like it compounds the thing, because like you have more garbage inside of the class, I think. It doesn't matter that much from this case, but I think on fundamental, like it compounds. Like the simple things are gonna compound, and then it becomes more and more complicated. Yeah, it should be. The other problem is this thing here, but I think this problem is more related to the flexibility, and they are connected. This is annoying is because I'm creating this stuff here, and then I'm determining whether or not I use this based on the flow here, like based on whether or not this worked, which is I don't like to do this. I don't like to select based on the name here. That's the problem. But I don't think there is a. The only way would be to couple the doc with the class, but it might be better to do it this way. So I guess the question I have to ask is whether or not because like the biggest benefits, so it's basically flexibility versus like simplicity. The biggest benefit of doing this way is because the way that I'm designing this is to be a generic class that I'm able to use on anything that I want. And this is what makes it hard because I don't know like what things I'm gonna create. So like I don't know if there's gonna be situations where it makes sense to put the icons here and then like put the nodes on another parts of the tree. Because this decision is gonna impact the layout of the structure of the tree, how the element works on relative to the structure of the tree. It changes the design of the thing that you're gonna put the element. So what would be the middle way here? Maybe this way is the best way. This thing I dislike. And I think this is related to the problem there, or the leak problem. So this is the question I have to ask: is like, is there a way to make it so that I know for sure that? Yeah. So the question is, why do I have to do this here? That's what I have to answer. So maybe I just step. I'm gonna step over the with the debugger, and I'm gonna use the delete. Now I'm having this. This problem I do remember. I think it's something to do with the sing and the cache. Yeah, it's because of the name. I think I don't remember really well. But there is something on the editor that there's some code on the editor when they are building the scene. But it's weird because now it's happening when I'm not. That's the reason why I set the name here. So there was a problem before that was getting an error like this, and it was because of the name of the root of the nodes. So the editor reconstructs the scene, and on one of the functions of the editor node, it gives us this error. I'm still not 100% sure why, but it has to do with the when the root of the scene doesn't have a name. It gives the based on the way that I'm building the scene there, it gives the error. But now I guess it's something else that is happening. So what should I do? I'm gonna put just to see. Oh, actually, it doesn't matter that much because I have to put the breakpoint here. So I'm gonna see this thing. I think I'm gonna spend some time going over, or actually, I have an idea before I do this. Is obviously I should, so I should comment out all of two of them at the same time. So I'm gonna do the variations here to see which one is causing the leak first. Then once I figure out which one it is, then I'm gonna review every place that I'm using the node that is leaking, and then I might step into if I can figure out by just looking at the code. Too many characters. I'm gonna just copy. I guess it's because of I'm using a single string probably. That's the issue. I should use both. I'll be right back. Actually, let me put the other thing. Yeah, so it probably was this one then. I'm gonna on comments or comments and then say, but it probably was this. Yeah, so it definitely was this. So it might be because hmm, it could be something to do. I think that even when in the way that I'm doing things, it is still gonna call this function. So if it is not hitting there, it might be because of it doesn't have a root, which means it might be because of here, but I guess the easiest way is just to put the breakpoint there and see. Yeah, I am using adds child external. So I'm gonna put the breakpoints on the on here just see. I guess I could move there instead of I should initialize the target here. Yeah, that makes more sense. I should initialize here actually. The content scroll container. I should probably put this on instead of a function as well. That way it's easier to change. Actually, I think I just because I put Hmm. I think it's because I can't cast Shadow. I actually should add directly instead. I was casting because you have to, I think hide and show only control nodes have hide and show functions. I think it makes more sense to add this. I'm gonna put this on a function and I'm gonna move the other thing there. So I'm just gonna move the main thing here to the function and I'm gonna change. Might be annoying though. I don't think I need to move because they are parts of the class. That makes it easier. Because that way, if I want to move to the constructor again, it's easier. And it makes it easier to understand what's going on. And the other thing I was gonna do, yeah. So I'm gonna move this stuff there. And now I think it's less likely that So I'm still gonna. Even if if it doesn't work, still to not have to free the queue there or queue free the class. I still think that it is probably much better to do it like this, because then obviously I make sure that I only initialize the class if I'm going to use it. If the other stuff worked. I also don't remember. I think I was using this to. There was a problem because of the width on the scroll container. Like there needs to be initial difference, I think. So that's why I was doing this stuff with the minimum to make sure that this is going to show, the scroll container is going to show. Hmm. Hmm. Maybe this was the problem. Maybe not actually. 'Cause I do remember I was using this. I think it has something to do with the scroll container, like the initial difference between. So there's the width of the parent of this class, which is a VBox container on the scene layout. So I think that the scroll container calculates based on the width of the parent and the child. But because the child is not, because it doesn't have a child on initialization on the way that I'm doing here, Usually you're supposed to have the child, but the way that I'm doing, obviously I'm not gonna have anything. Like I once you have the option to not have anything, I think. I can also just add the first one here. So I think that the scroll container is gonna calculate whether or not it's gonna show the slider of the width based on the width of the child, the direct child, and the width of the parent. I think that's the reason why I was using this minimum size here. Because this is gonna be the minimum size of the children. No. Oh, the minimum size of the parents. Yeah, this is the minimum size of the parents. And then you have the minimum size of the child. Yeah, I was gonna have if I added uh I think I was adding here the first one. First element. Nice. So it did solve. The problem now is gonna be like it might be fucked up there. I have to so I'm gonna have to change. I have to hide the elements here, and then I'm gonna put this function here, and then I change the function so that I use the getting icon. I'm gonna do a special name for the file system presenter, which is the other class. And then the other ones I just use the name of the class. I need to see. I'm gonna test first just by passing the name, even though it doesn't have the default doesn't have. I think it doesn't have panel SVG. Also, it does have. This the editor has, but the default theme doesn't. But I wanna test to see what happens if I pass and it doesn't have. So if I call this function, it doesn't have the item. But I should probably put a warning anyway. So I check first to see. Yeah, but then how do you check? That's the thing. Yeah, so that's the reason why I wanna. So I have to see what happens when you don't have the thing, what the function returns. Then I put a check based on what it returns. And the other situations, I can put a custom name if I want some class to have a custom an icon for custom name, which is what I'm gonna do with the file system presenter. And yeah, I have to hide the elements. Yeah, this is fucked up because of the I'm adding everything. Should yeah, at least it's not crashing. I'm gonna remove the thing on the node. Actually, it's better to do it from here because of the breakpoints. So I'm gonna do the hide first, and then that should be here. So I think for the hide, they have to cast. and it has to be inside of the tree. So it might break because of that. I think I'm gonna make it based on the. I can put here already. Yeah, the question is, what happens if I put a node that is not a control there by mistake? You should probably put a warning. I just still. Mm. What you think now with the file system? Press enter. Yeah, just inherits from node. Node inherits from object. No. So I copied this directly from the file system doc. But it's interesting that it was working before. Hmm. Like the main reason why it has to be control, I think, is because of the hide function. Yeah, so I guess I'm gonna have to make this a control. Problem is I'm not pretty sure if it's gonna mess up the. Cause I straight up copy it from this other one, which was the file system doc. Actually, maybe we didn't do that. Yeah, I think I was pretty sure that I copied. I think I copied from somewhere else, but maybe I didn't copy from the same thing. Because this one is gonna be a control somewhere along the line. Yeah. Mm. So I need to think about another. I'm gonna ask ChatGPT how to get the type of the class. Actually, actually, I already have the name because I know I'm gonna instantiate from that. So I'm gonna ask ChatGPT still, but because it might be better to get from the object. Fuck. Yeah, get class. So this maybe this works. But now I changed the other one, so maybe it's not gonna show. If it does, I'm gonna change again to node to see if the message is gonna print the type of the class. So I'm glad I had this error because then forced me to fix there. I still think I have the problems there, but I'm not really sure if it's worth it to focus on this now. I don't even know if there is a good solution. The thing that I'm thinking about is like, I'm not even sure if changing the engine to a more a true entity component system, which is more composition, if it would solve this problem, because I think it's a different kind of problem. It has to do with the cache and side effects. I think it's hard to cache side effects, and that's where what it comes down to. I think I'm gonna ask ChatGPT just out of curiosity, because maybe it probably has some interesting things to say about this. But I do think that this is probably the core of the issue. Is how do you cache side effects? And I think that like it has something to do with monads, but not directly. I think indirectly it has because of the as far as I understand, a monad is a functional structure that you can use uh, to have side effects basically. I think that that's the purpose of a monad. The main one of the main purpose because it allows you to compound the. Yeah, but I'm not really sure if that's the purpose. So I'm gonna ask ChatGPT this as well. Yeah, so now it shows the name of the class much better. So I have two main questions. One is how to cache side effects. How to cache side effects. The other one would be how are monads related to side effects? What is the main purpose of a monad? I'm gonna ask this one first. I'm gonna open a new chat there. Then I'm gonna ask this one. Then after asking this one, I'm gonna ask the other one because there will probably be a chance that it will incorporate monads on the answer of the side effects, but I'm not gonna explicitly ask it first because I want to see if it is gonna make the association based on the previous prompt. So I want to see if I remember the signature. I don't remember the rest of the stuff, but just I think the first argument is a function that takes fhfb. Then the second one is another. I think that the first one is probably the first one I think is from what I remember ma. Then the other one is it takes a from it's a function that takes a to mb, and then the other one is mb. Yeah, I think that's what a monad is. So you start off with so this is the part that is very confusing and I'm trying to clarify. But basically, this is like putting the thing on a context. But this is kind of weird to me because like I think that the name is like this would be the same. This would be the same thing as a product type. So the context, the example that ChatGPT gave last time that I asked this is with the just, and I assume that's how most people use it. So I have just A, and then you turn to just B, and the reason why is the just is kind of like it is similar to option I think on C++, and it's just something that people use to check for errors I think. But I don't understand like what does that mean? Like underneath the thing, what is how does that make sense? Because the A in this context would be like a generic template on C++. So usually the keywords the paper uses T. So it's like template then class T. So it's like a generic type that can become any type you want. So it could be a string, it could be an integer, or it could be something else. Then this is putting, I think it is kind of like creating a tuple where like we're gonna have two different generic types on a tuple of two different generic types. So this would be like the first argument of a function. Then the second argument would be another function that is supposed to transform one of the template types into a tuple with the other one. This part I'm not 100% sure. I'm gonna ask this again as well, just see, because I don't know if this is correct or not. On the concept level, I think the easiest way to understand is a flat map. So a monad is a flat map. So I have a structure, and that structure holds types. And when you change the types that the structure hold, but maintain the structure, that's a monad. So I'm gonna ask what is the signature, or what is the declaration?
World computations often involve side effects, such as reading, writing files, generating random numbers, or interacting with external systems. Monads allow you to encapsulate side effects in a controlled manner. They don't eliminate side effects, but rather package them into a type, e.g. IO maybe state, that clearly indicates their presence. Sequencing. Computations monads provide.
Yeah, so they allow you to encapsulate side effects. So it is related.
Object target object equal to class DB instantiate. My object target object. Monads are a powerful concept in functional programming, especially in languages like Haskell, where they provide a structured way to handle side effects while preserving the purity of the language. Here's how monads relate to side effects and their main purpose. Monads and side effects. Encapsulation of side effects. In functional programming, functions are expected to be pure no side effects, always returning the same result for the same input. However, real-world computations often involve side effects, such as reading, writing files, generating random numbers, or interacting with external systems. Monads allow you to encapsulate side effects in a controlled manner. They don't eliminate side effects, but rather package them into a type, e.g. IO maybe state, that clearly indicates their presence. Sequencing. Computations monads provide a framework for chaining operations where each step might involve a computation with side effects. The sequencing ensures that side effects occur in a predictable order, maintaining purity in the language by isolating effects within the monad's context. Isolation. Through context, monads context, e.g. IO A, maybe A state SA, represents computations that may include effects, e.g. producing a value, failing, or manipulating state. This context ensures that the side effects are not mixed with the pure parts of the code. Main purpose of a monad. The main purpose of a monad can be summarized in these points. Abstracting computation patterns. Monads abstract common patterns of computation, such as chaining operations, managing state, handling failures, or asynchronous computations. They provide a uniform interface bind in return for dealing with such patterns. Composition of effectful functions. Monads enable the composition of functions that produce values wrapped in a context. For example, they allow you to compose functions of type A greater than MB and B greater than MC to produce a function of type A greater than MC, maintaining purity. By encapsulating effects, monads help keep the core language pure. All effects are tracked explicitly in the type system, making the flow of side effects predictable and easier to reason about. Separation of concerns. They separate the what, the core logic of the program, from the how, the handling of effects or context. This separation makes programs more modular and easier to refactor. Analogy. A recipe for side effects. A monad can be thought of as a recipe or blueprint for handling side effects. It tells you how to process inputs and manage effects step by step, ensuring that everything happens in a controlled, predictable manner. This encapsulation allows functional programmers to reason about side effect laden computations as if they were pure, while the monad takes care of the details.
So it's definitely related. So I do think that is basically the same problem, but in different levels. So the question would be, so maybe it is possible to use the monad to cache the state in a easy, cache the side effects in an easy way. So maybe that's what I should do. As obviously I'm gonna ask more about, because even though you can encapsulate, I've been struggling, like this is by far the hardest part of learning functional programming, because there's nothing that translates very well. Like there is, but I'm not very used to, like on Rust you have interfaces, I think, and on C++ you're gonna have concepts. So is the concept is not the concepts on C++, but the principle is ad hoc polymorphism, the way that they talk about it. And it's kind of hard to understand. And this goes like one of the reasons why it's hard is because of this distinction of a type constructor and a value constructor. So a value constructor is something that allows you to create a value. So like the difference is it comes from category theory, I think. So basically you have like a type is like a set, so it's a collection of objects, and then objects are parts of the sets of the type. So for example, like here you could have like an integer. So the type is the integer, and then the objects of the type are going to be like the numbers, the natural numbers, I think. So a value constructor would be like creating a value uh, out of the same type. So if you have like 2 or 5, that would be a value constructor. But the thing that it makes it confusing is that on Haskell is going to be like a letter in the same way that the type constructor is a letter. So, but one of them is going to be used to build the set type, and the other one is used to build the value of that type. But the distinction is not very clear because they're both used on the context of product types. So usually what's going to happen is that, as far as I understand, we're going to have the data constructor, the data keywords, which is going to allow you to create a new type. And then from, I think, like the example that ChatGPT uses is maybe, and I think it has another one, which is gets into the point that I'm saying that's very confusing. And then it's either nothing or just a. So as far as I remember, this is the declaration of maybe. So in this case, maybe I think it would be the type constructor. The a would be the value constructor, and just and nothing would be type constructors as well, I think. But maybe nothing would be the value, and that's the part that is confusing. Because here is written as if it is a product type. So why are they on different levels? I think that's the thing that I have to clarify. So like in this case, for example, just would be the int here, and a would be an object of the int stat. Well, obviously just is not int, it's just different stats, but it's a type. And I think this makes it hard to understand the other concepts as well because of the way that is written, and the distinctions are not very clear. So like intuitively, it's kind of easy to understand if you just read, but then like the fundamental thing behind is very hard to understand how it works.
In Haskell, a monad is a type class defined in the prelude, and more formally in the control.monad module. Here is its declaration and explanation of its components. Declaration of the monad type class. Haskell copy code class applicative m equal to greater than monad m, where greater thanked, ma greater than mb, greater than mb bind operator, greater than ma greater than mb, greater than mb then operator optional override return, a greater than ma, wraps a value in a minimal context fail, string greater than ma handles failure deprecated. Components explained. Bind type ma greater than a greater than mb greater than mb. This operator is the core of a monad. It takes a value inside a monadic context ma, applies a function that produces a new monadic context a greater than mb, and returns the result in the same context mb. Example Haskell copy. Code just 5 greater than equal to x greater than just x3 result just 8 greater than then type ma greater than mb greater than mb. This operator sequences two monadic actions, discarding the result of the first. It is often defined in terms of greater thanked. Haskell copy code m greater than mb equal to ma greater than equal to greater than mb. Example Haskell copy code just 5 greater than just 10 result just 10% return type. A greater than m wraps a value in a minimal monadic context. It does not involve any computations or effects. Example Haskell copy code return 5 maybe int result just 5 fail type. String greater than m provides a way to signal failure primarily in pattern matches within do notation. However, it is deprecated in modern Haskell because it violates the monad's purity in some contexts. The recommendation is to use explicit error handling mechanisms like maybe or either. Minimal definition. To define a monad instance, you only need to implement bind return. The other functions greater thanked fail can be derived from these. Example monad definition maybe. Here's how the maybe type implements the monad type class. Haskell copy code instance monad maybe where return x equal to just x, wrap a value in the just constructor nothing greater than equal to nothing just x greater than equal to f apply the function f to the value inside just fail equal to nothing deprecated but implemented for completeness. Usage example Haskell copy code using bind just 5 greater than equal to x greater than just x3 result just 8 nothing greater than equal to x greater than just x3 result nothing. Monad laws. Any monad instance must follow these laws. Left identity Haskell copy code return greater than equal to f equal to f wrapping a value with return, and then applying a function should be the same as applying a function directly. Right. Identity Haskell copy code greater than equal to return equal to m binding a monad with return should not change it. Associativity Haskell copy code greater than equal to g equal to m greater than equal to x greater than fx greater than equal to g. The order of chaining functions should not affect the result. These laws ensure that monads behave predictably when used in compositions.
I'm gonna ask a couple of more questions about Haskell before I ask the question about the side effects, how to cache side effects. But I do think now, I think that this might be an interesting thing to try to do. So like the way that I solve the problem there is by implementing a monad to capture side effects, and then I figure out how to change the cache system so I can cache the monads. That might be the way to solve that, if it is possible to do this. And then obviously I'm gonna have to think about how that's gonna go together with the rest of the things. Because the main components, like you have functions that create scenes, and then you have classes that create the parts of the scenes. And then the communication between them are the side effects, which are basically signals, and this additional information that you create outside of the class to change the behavior of the class. So I think whenever I have dependency injection, and you don't want to capture that dependency injection on the class. Dependency injection is just a fancy way to say that you're gonna pass. I think usually is used in the context of classes. So, but I think it serves with anything. Like you pass a data structure to another class to change the. But I think usually for dependency injection, you're probably gonna make it a variable of the. Like you have a member variable of a class that is another class, and then you pass that as a inside of the constructor to initialize the class. And so basically, I think that the so another question I should ask obviously is whether or not like does this mean that I have to change the way that it works there, or is the way that I'm thinking about it the wrong way to think about it? And like it's just an indication that I'm not thinking about it in the correct way. Because it could be the case that I should design the classes in a way that I always can cache everything, and the way that I'm thinking about it is not correct. That can also be the way, but I'm leaning more towards the like I think the optimal solution is probably one that is going to require side effects because of the nature of the relationship between things. So I do think that like it's going to be a fractal pattern. So all the things are going to contain islands because it's directly correlated with density. So like the frequency of repetition of something determines the density that it has, and that's the structure of space-time. So the more times you are going to use something, the more solid it becomes, and the more incentivized you are to. But this is I kind of changed my mind a little bit on this because of ChatGPT. So it might be the other way around because the way that I was thinking before is a gradient where I had like functional programming on one side and then object oriented on the other side. And then I had procedural in the middle. Because obviously everything is going to be a gradient because it's just a reflection of the polarity of the electromagnetic field. So like space-time itself is a multifractal gradient. So everything you see, like all the concepts are going to be relative multifractal geometry, which is the exemplification of the gradients between things. So I was looking into this and I was thinking about it like this. But then after talking with ChatGPT a little bit, I realized that it's probably different, that the procedural is on the other end, object-oriented is on the middle, and the reason why is because what determines this gradient is the side effects. So immutability, because this is immutable and doesn't have side effects. And this one does have side effects and mutability. And then the object-oriented is somewhere along the middle. So I think that's what is happening there when the way that I'm creating things is that the scene is gonna be, but this is the thing because it's not. I think the scene is more procedural. It's not functional. Yeah, it's not like I'm using it because the very concept of creating the scene is like it is kind of like incorporating side effects. I'm not really sure if that's the correct name to put it. Because outside of the additional data you can theoretically use to change the state of the classes as you're building the scene. The main purpose of the scene would be to connect the different nodes, so connect the objects. But I don't think that classifies a function as functional programming, because the purpose of the function is not to convert one type to another type. maybe this would be just object, but it's not really object oriented because it's like an external function. But I guess you are like, but this is the thing, you're not changing the type, you're changing the structure of the object of the type. So you maintain the type, you just change. Hmm. So I have to think about a way to ask this question as well, ChatGPT. I guess I'm just gonna explain what I'm thinking, and then I'm gonna ask based on that. So if I have a function which is purpose is should create, not create. Oh, robots, nodes. Just gonna do. Uh, I guess this is the prompt. Yeah, but I gotta I have to get there through the side effects thing. So I'm gonna first ask to. Yeah, so it is the way. At least I remember how it is. So maybe it's a type constructor, type parameter, generic type, and represents maybe a value of type A, or maybe nothing. It might be based on the lowercase and uppercase of the first letter of the name. Read this message.
The maybe type in Haskell is an algebraic data type used to represent an optional value, meaning a value that might or might not exist. Its declaration is as follows. Declaration of maybe. Haskell copy coded data maybe a equal to nothing, just a components explained. Data maybe a. This declares a type constructor. Maybe that takes one type parameter a. Maybe is a generic type and can represent maybe a value of type a or maybe nothing. Nothing a data constructor indicating the absence of a value type. Nothing maybe a polymorphic works for any type a just. A data constructor that wraps an actual value of type a type just. A greater than maybe a takes a value and wraps it in the maybe type. Example usage. Creating values. Haskell copy code example 1. Maybe int example 1 equal to just 5. A value wrapped in the maybe type. Example 2. Maybe int example 2 equal to nothing. No value. Pattern matching. You can use pattern matching to work with maybe values. Haskell copy coded describe maybe string greater than string describe nothing equal to no value describe just s equal to the value is f. Example calls. Haskell copy coded describe nothing. Result no value describe just hello. Result the value is hello. Why use maybe? Avoiding null pointers instead of null or nullter. Haskell uses maybe to explicitly represent the possibility of missing data. Explicit. Error handling. Functions that might fail or produce no result often return a maybe value, forcing the caller to handle both cases explicitly. In Haskell, type constructors and value constructors are differentiated based on where and how they are used in the language. While both are introduced in the same data declaration, their roles are distinct. Key differences between type constructors and value constructors. Aspect type constructor value constructor role defines a new type, creates values of that type, where it appears in the type signature or definition, in expressions or patterns. Functionality takes type parameters, if any, and produces a concrete type, takes arguments, if any, and produces a value notational way, starts with a capital letter, always starts with a capital letter. Array operates on types, e.g. maybe a dot operates on values, e.g. just 5. Example, maybe type declaration. Haskell copy coded data. Maybe a equal to nothing, just a. Type constructor maybe. Maybe is the type constructor. It takes one type parameter a and produces a concrete type, such as maybe int or maybe string. Example of type constructor usage. Haskell copy code myval. Maybe int maybe is the type constructor here myval equal to just 5. Value constructors. Nothing and just. Nothing and just are the value constructors. They create values of the maybe a type. Examples of value constructor usage. Haskell copy code example 1. Maybe int example 1 equal to nothing. Example 2. Maybe int example 2 equal to just 42. Just is a value constructor here. Differentiation by context. Haskell differentiates between the two based on context. In type context, when used in type signatures or type definitions, a name refers to a type constructor. Example. Haskell copy coded data my type a equal to my value a. My type is the type constructor x. My type int. My type int is a concrete type in expression context. When used in function definitions, expressions, or pattern matching, a name refers to a value constructor. Example. Haskell copy. Codex. Maybe int x equal to just 5. Just is the value constructor. Describe maybe int greater than string. Describe nothing equal to no value. Nothing is a value constructor. Describe just and equal to value is show n. Rules to remember. Type constructors appear in type signatures. Maybe int means the maybe type constructor applied to int value constructors. Appear in code that constructs or manipulates values. Just 5 means the just value constructor applied to 5. Type constructors only operate on types, while value constructors only operate on values. Wrong usage. Mixing roles. Haskell copy. Codex equal to maybe 5 error. Maybe is a type constructor, not a value constructor. By maintaining this distinction, Haskell enforces clear separation of types and values.
Like there is this thing called lambda calculus, and then there is logic proofs that people talk about, and they draw like some line. Like you make a statement that with a lambda function, I think, get on a context, and then based on that statement, you have a line that has other statements that's like depend on the first one, and that way you derive. So like this stuff is related to type resolution on compilers. So I assume like it's something similar to this, but it's probably because the answers are not exactly what I'm looking for, but it's probably because I still don't have the right picture in mind to be able to ask the right questions to clarify what I'm confused about. But it's definitely related to this relationship between value and types. Because I think that the way that you create the connection between both, the way that, especially the way that is written in Haskell there, is very confusing to me. I think it's because of that and because of the product types. I think that when you have a product type, you have a type constructor, and then you have different values. A type constructor with more than one value constructor. But I think one of the reasons why I'm struggling is because there isn't a direct equivalent on C++. Because I'm thinking more about like when I think about the value constructor, I think about the actual object and not the or like let's say 5 or something like that. And I'm not thinking about the template. So I think the template should be a type constructor, not a value constructor. So I guess this is probably what I should ask. Like, what is the difference between the way that, or I should ask if C++ has what is C++ value constructor? How does it resolve the type from the value constructor? Yeah, that's what I'm gonna ask.
Haskell determines whether it can construct a type from a type constructor and a value from a value constructor through its type system and data declarations. Here's how it works for each case. Constructing a type from a type constructor. 1. Type constructor array. Haskell checks if the type constructor is provided with the correct number of type arguments array as defined in its data declaration. A mismatch in the number of arguments results in a compile time error. Example, the maybe type constructor. Haskell copy coded data maybe a equal to nothing just a. Maybe has an array of 1. It takes one type argument a to form a concrete type. You must supply exactly one type. Haskell copy code maybe invalid. A equal to int maybe int valid. A equal to maybe int maybe error. Missing type argument. 2. Kinds. Each type constructor has a kind, which describes the number and types of arguments it expects. The kind of maybe is greater than, meaning it takes a type and produces another type. Haskell checks kinds to ensure type arguments are compatible. Haskell copy code maybe int valid. Int has kind maybe error. Maybe has kind greater than not. 3. Polymorphic type variables. When a type constructor has polymorphic variables, Haskell ensures the supply type arguments satisfy the generality implied by those variables. Example, Haskell copy code data pair b equal to nk pair b. Pair is a type constructor of kind. Greater than requires two types. Valid. Concrete types. Haskell copy code pair int string pair bool maybe int invalid. Haskell copy code pair int error. Missing one type argument pair maybe int error. Kind mismatch. Maybe has kind greater than. Constructing a value from a value constructor. 1. Data declarations. Haskell uses the data declaration to determine which value constructors exist and what arguments they require. The type signature of each value constructor specifies what kind of value it can create. Example, the maybe type. Haskell copy code data maybe a equal to nothing just a. Nothing maybe a nothing takes no arguments and produces a value of type maybe a just. A greater than maybe a just takes a single value of type a and wraps it in a maybe. 2. Type checking. When a value constructor is used, Haskell checks if the supplied arguments match the expected types in array. If they don't, it raises an error. Examples. Haskell copy code nothing maybe invalid. Nothing works for a maybe a just 5 maybe invalid 5. 3. Pattern matching. When destructuring values with pattern matching, Haskell checks whether the provided pattern matches the type and structure of the value. Example, Haskell copy code case value of nothing greater than no value matches nothing just x greater than value is show x matches just and binds x. Summary of how Haskell figures this out. For type construction, it checks the array number of type arguments and ensures the kinds match it. Ensures polymorphic type variables are instantiated correctly. For value construction, it checks if the value constructor exists for the type being constructed. It ensures the value constructor's array and argument types match the declaration. It ensures the resulting value aligns with the expected type context. Haskell enforces these checks at compile time, ensuring the programs are type safe and well formed before they run.
I guess I have to ask the other thing first. As both the question of like how does it know what makes you stop being able to initialize 5 as a string? So how does it determine what it means to have the 5 and have this string? I think this is related to the value constructor, but I'm not really sure what is the best way to ask this. I have to ask this first before I ask the like how does the type, but I guess it's kind of the same question. This already know the answer, but I'm still gonna ask. It's gonna talk about lambda calculus, and it's gonna say that on lambda calculus you can have values that don't have types, but on programming all the values have types. So like a value that doesn't have type would be like a scalar on mathematics. And I think the types are the units, which goes into the stuff about the 1 times 1 equals 2 thing, about the Terence Howard thing. And I think that the reason why is because of the assumptions on mathematics. I think that's the difference. And the ChatGPT agreed with me. Like before, I thought like I heard someone say that computer science is a bigger set than mathematics, and I disagree with that. And I thought that mathematics is bigger than computer science. But then I changed my mind and I was thinking more that it's probably two sides of the same coin. But ChatGPT thinks that mathematics is bigger than computer science. Not sure if it stopped.
In C, the concepts of type constructors and value constructors aren't explicitly named as such, but analogous mechanisms exist. Here's how they compare, and how value construction works in C type constructors and C templates act as the closest analogy to type constructors in Haskell. A template can take one or more types as parameters and produce a new type. Example, template is a type constructor. CPP copy code to template less than TP name T greater than class box T value, public, box of val, value val, boxless than greater than is a concrete type produced by the box template type constructor. Similarly, boxless than T, string greater than is another concrete type. C++ ensures that the template arguments are valid types, and it performs checks during instantiation to determine if the resulting type is constructible. Value constructors in C and C value constructors refer to constructors defined within a class or struct, used to create instances values of the associated type. Value constructors are explicitly declared using the same name as the class or struct. Example, value constructor. CPP copy code class point in xy, public, point in xval, int eval, xxval, eval, value constructor. Point P10, 20, constructs a value of type point. How a value constructor works. Definition in class. A value constructor is a member function defined in a class to initialize an instance object of that class. Invoked. During object creation, when an object of the class is created, the constructor is called automatically. Passing any arguments is required without responsibility. Constructor initializes the object's member variables and performs any setup required for the object. How does C++ figure out if it's possible to construct a value? Type matching. C++ checks if the provided arguments match one of the defined constructors for the type. No matching constructor exists. The compiler raises an error. Default constructors. If no constructor is explicitly defined, C++ generates a default constructor if possible, which initializes the object with default values. Argument conversion. If the constructor requires arguments, C++ checks if the provided arguments can be implicitly converted to the required types. Example, matching a constructor. CPP copy code class point int xy, public, point int sval, int eval, xval, eval, valid construction, point p10, 20, matches point int, invalid construction, point qlo, 20, error, cannot convert const char to int. Is a value constructor always associated with a type? Yes, in C. A value constructor is always tied to a type. Every value constructed in C++ has an associated type. Even primitive values, e.g., integers, floats, are implicitly associated with fundamental types defined by the language. Examples of constructing values in C: primitive values constructed directly using fundamental types. CPP copy code int a equal to 10 constructs an integer value user-defined types, always tied to a class, struct, or other user-defined type. CPP copy code point p10, 20 constructs a value of type point anonymous temporary values. Even anonymous values have types. CPP copy code auto temp equal to point 12 temporary value of type point. It is not possible to construct a value in C++ without an associated type because the type system ensures every value is explicitly or implicitly tied to a type. Summary: type constructors in C templates act as the closest analogy to type constructors, producing concrete types from type parameters. Value constructors in C defined in classes, structs to initialize objects. They work by ensuring argument types match constructor signatures, not determining constructibility. C++ checks if a matching constructor exists for the given arguments, not implicit conversions. Can satisfy constructor parameters. Default constructors or copy constructors are available. Every value has a type. Every value in C++ must have an associated type, whether it's a fundamental type, a user-defined type, or a template instantiated type. Constructing a value without a type is not possible in strongly typed programming languages like C++. How is type enforced during value construction in C? Object target object equal to class DB instantiate. My
I guess it was finished on the other answer, so I'm not gonna read this one. Oh, so a product type uses a type constructor, so the letters are gonna be interpreted as types and not as values. I think that's the. Mm. Oh, I think the letters are value constructors, but a value constructor is a type.
Yes, in Haskell, when you declare a product type, all the values constructed by the constructors of that type have the same type, which is the type of the data type itself. The different constructors are simply different ways of constructing values of the same type. What is a product type? A product type combines multiple values or fields into one. Each field can have its own type, but the combination of these fields represents a single value of the product type. Example, product type in Haskell. Haskell copy coded data point equal to point int. Point is the product type. The constructor point combines two int values into a single value of type point. Example, usage. Haskell copy code point p equal to 0.34. Here, 0.34 is a value of type point. All values produced by the point constructor belong to the same type. Point r. All values of a product type the same type? Yes, all values constructed by the product type's constructors belong to the same type. For example, Haskell copy coded data person equal to person string int. Person Alice 30 and person Bob 25 are both values of the same type. Person. Does this hold for types with multiple constructors? Even if a data type has multiple constructors, all values constructed by these constructors still share the same type. Example, data type with multiple constructors. Haskell copy coded data shape equal to circle float rectangle float float. Circle and rectangle are constructors. Both circle 5 and rectangle 4 6 are values of the same type shape. Haskell differentiates these constructors internally, but treats all values they produce as having the same type shape. How does this work? The type shape is the overarching type. The constructors circle and rectangle provide different ways to construct values of the same type shape. Pattern matching is used to distinguish between different constructors at runtime. Example with pattern matching. Haskell copy code area shape greater than float area circle r equal to pi r area rectangle wh equal to wh here. The function area operates on values of type shape regardless of which constructor circle or rectangle was used to create the value. How is this different from some types? The distinction between product and some types lies in how constructors combine fields. Product types combine multiple values fields together into one value. Example. Point and int some types provide alternatives for constructing values. Example. Shape equal to circle float rectangle float float. Even in some types, all values still share the same overarching type shape in this case. The constructors only define how the values are represented or constructed. Summary. In a product type, all values constructed by the types constructors have the same type, which is the type of the product itself. Constructors combine multiple values into one. Even in types with multiple constructors like some types, all constructed values share the same overarching type.
I mean, maybe I should finish this stuff here before I ask all the other questions. So I think like I already solved the biggest problem there. So I think that what I have to do now is just change. It's just gonna be minor stuff, so I'm not really concerned about it, I think. So I'm just gonna change I'm gonna call maybe like this one is already easy enough, so I'm just gonna change put here. And then what I'm gonna do is maybe I'll already do this as well, so it doesn't take. So I just put here. Oh, also I still haven't seen. So I'm gonna do these changes first, and I'm gonna open on the thing there. Let's see if I'm gonna do the same now. I'm gonna change later. So obviously I'm gonna do the other one based on the name. Actually, delete. The other thing that I'm gonna think about is to change the yeah, the other thing goes into the stuff about monad that I'm asking there. So this might be very interested on this, so I do want to spend time on this now because it might help me solve the problem as well. So it's gonna kill two birds with like three birds with one stone actually. Like one's gonna be understanding monads better. The other one's improving a Haskell, and the other one's gonna be to solve the problem. So I think it's probably it's like clearly a very good thing to focus on. So I think the fundamental thing is these two questions here. So like one is what is the best way to cache, or maybe how to cache side effects, and the other one is how to. I already know now that monads are related to side effects. So it's basically a functional construct that allows you to encapsulate side effects by connecting functions together. So by composing functions, you can retain side effects using functions. So I guess the other question would be, is it possible? Well, obviously, I want to spend more time with ChatGPT asking a bunch of questions, and then like to see if I can come up with better questions to clarify this stuff here. But would be like, is it possible to use monads in order to facilitate or something like that? Caching side effects. The plan would be incorporate monads on the Cortex project so I can or a cache is not very good, is serialized. Something along those lines that I wanna see if it's possible. Because if I can do this, then I think it's gonna be easier to think about. But like, it would probably become a different thing, the way that I'm thinking about it. So like, it's gonna be a mix of class with monads or something like that. Because the way that I think, like, I would probably create a system that I cache the system. So it's very similar to what I was trying to do, and then I figure out that is not necessary with the signal serialization, because they already have functions to serialize the signal. Is an option you can put when you're calling the connect function to serialize the signal on the sync file. But it would be very similar where, like, on that situation, that example, I created a class, and then I was using the class to cache or to serialize all the signals of the scene based on based on the class properties. So I think that would be something along those lines, but different. So like instead of using a class, I would use a monad somehow, and then from that monad, I would be able to serialize the information of the side effects of whatever I wanna save. Then I would probably use that like in a systematic way to whenever I encounter a situation like this, because the main thing that I want to do. So I could make it based on a property either way. But the thing that is kind of annoying of making it as a property and then saving, serializing as a property is that it's gonna expose the thing to the editor. I'm not really sure if that's like maybe on this situation doesn't matter, but probably on some situations it does. So let's say I don't want to expose the icon customization on the editor or to other classes. I want to make it exclusive to this one. Then I won't be able to make it as a property because the moment you make as a property and you add there, just save, cache on the scene, just save on the scene file, it's gonna expose that property on the editor, which is gonna allow people to change. So the main thing that I want to do is instead of looping over the directory, I loop over a vector of string names, and then based on the string names, I select the icon from the default theme. But in order to do that, I would have to either create a function or something outside, then I would have to call the whatever I create from here. So where is the so I'll create here, for example, vector string name sing tab icons. Then I push whatever I want here. And etc. Then I pass this either on the constructor of the class, or I would pass, I would create a function on this class here, and then I would push or set the value. So it would be either a property or just based on the constructor. And if I do based on the constructor, then I can't do, it has to be based on a function, but the function doesn't necessarily have to, I don't necessarily need to put as an argument. I can change I can call the function from outside the init. And like I said, it doesn't really matter for this case. I think it's more like a systematic thing, and a fundamental thing that is important to think about. And it's gonna help me on every like other situation as well. So it's not only to this. It's like it is first principles kind of thing. And so this is a problem. So it means that basically the post initialize is gonna happen before. So I'm gonna try to put here and see if it complains. Which it probably will, I think. So either I have to move this functionality to the other one, which I'm not pretty sure if it's good. Or there's two different events that it says there on the warning that you can use get theme icon. If neither of these things are possible, then I can just do it. Actually, the problem is that I'm gonna have to. Yeah, I can loop over the buttons later. It's not very good, but I don't think is that big of a deal. Because I can separate the moment that I create the icons on the button and the moment that I initialize the classes. So it doesn't matter that much. And also, still a weird error here. I'm probably gonna look into this stuff later. I don't think that's. I think this stuff about monads is far more important.
Great questions. Let's clarify the roles of type constructors and value constructors in the context of your examples. 1. Are int and float value constructors and point int? No, int and float and point int are types, not value constructors. Here's the breakdown of point int. Point, a value constructor. It creates a value of type point. Int, a type, specifically a primitive type in Haskell. It's not a constructor but rather a predefined type. Two int values passed to the point constructor are actual data values, e.g. 3, 4, 42, not value constructors. Example, Haskell copy coded data point equal to point int int. Point p equal to point 3, 4. Point is the value constructor. 3 and 4 are values of type int. So, point is a value constructor. Int is a type, and 3 or 4 are values of type int. 2. What about maybe? Here's the definition again. Haskell copy coded data maybe a equal to nothing, just a. Breaking it down, maybe a type constructor. It creates a new type, like maybe int or maybe string. Nothing. A value constructor. It creates a value of type, maybe a, e.g. nothing is a type. Maybe int when equal to int just. A value constructor. It takes one value of type a and produces a value of type maybe a. Is a value constructor and maybe? No, a is not a value constructor. It is a type variable that represents a type, and its specific type gets determined when maybe is used. Example, if we use maybe int is a concrete type constructed by applying the maybe type constructor to the type int. Nothing is a value of type maybe int. Just 42 is a value of type maybe int, where 42 is a value of type int. So a is a type variable, not a constructor. In maybe a, it can be replaced by any type, e.g. int, string, etc., but it is not a value. Key difference between the examples. In point and int, point is a value constructor that takes two values of type int. Int is a type, and the values passed, e.g. 3, 4, are actual data. In maybe a, just and nothing are value constructors. A is a type variable, a placeholder for a type, not a value or constructor. Just a means a value of type may be constructed with a single value of type a. Summary: int and float are types, not value constructors. Values like 3 or 4.5% are data of those types in maybe a is a type variable, not a value constructor. Value constructor like point or just is a function that combines data into a value of the type it defines, e.g. 0.34 produces a value of type point. In short, type constructors work at the type level, and value constructors work at the value level. They are separate concepts but work together when defining and using data types in Haskell.
It's probably the last question I'm gonna ask related to this, and then I'm gonna ask about the side effects.
The concepts of type variables and type constructors in Haskell are fundamental, but they serve different purposes and operate at different levels of abstraction. Let's break down the difference between them. 1. Type constructors. A type constructor is used to construct new types. It operates at the type level, similar to how a function operates at the value level. Type constructors are used to create concrete types for more general or abstract types. Example of a type constructor. Haskell copy coded data maybe equal to nothing, just a. Maybe is a type constructor. It takes a type as an argument, e.g. int, string, etc., and returns a new type. When you apply the type constructor maybe to a specific type, you get a concrete type like maybe int or maybe string. Maybe int is a type that represents a value that can either be nothing or just an int. Maybe string represents a value that can either be nothing or just a string. Type constructors are similar to functions, but for types, they take types as input and return new types as output. More examples of type constructors. List is a type constructor. It takes a type like int or string and produces a list of that type like int or string. Tuple is a type constructor that takes two types and produces a new type like int, string. 2. Type variables. A type variable is a placeholder for any type. It represents an abstract type that can stand for any specific type when the function or data type is applied. Type variables allow you to write generic functions or data types that can work with any type. Example of a type variable. Haskell copy coded data pair b equal to pair b. A and b are type variables. They are placeholders for any types, meaning that pair a b can represent pairs of any types. When used, you can substitute a and b with specific types like pair int string or pair bool double. Type variables enable polymorphism, where a function or data type can work with any type without needing to know exactly what that type is. More examples of type variables. In a function like id, a greater than a is a type variable, which means the function id can accept a value of any type and return a value of the same type in. The maybe type declaration, a is a type variable, meaning maybe can represent a maybe for any type, maybe int, maybe string, etc. Key differences. Aspect type constructor type variable definition a type level function that creates new types. A placeholder for any type in a generic context. Purpose used to define or create new types. Used to make types polymorphic or generic. Takes arguments, takes types as arguments and returns a new type. Does not take arguments. Represents any type. Examples maybe either a, b, x, y's role defines. The structure of data types represents a type that can vary a generic type. How they work together. Type variables and type constructors work together in defining generic data types and generic functions. Example: generic data type. Haskell copy coded data pair b equal to pair b. Here, pair is a type constructor that takes two type arguments like a and b. A and b are type variables that can be substituted with any type. Example: generic function. Haskell copy coded a greater than a id x equal to x. Here, a is a type variable that makes id a generic function. It can accept and return any type, e.g. id 5 works for int and id hello works for string. Summary: type constructors, functions that create new types from existing ones. They define the structure or shape of data types, e.g. maybe. Type variables, abstract placeholders for types. They allow for generic or polymorphic behavior, making functions and data types applicable to many different types. Together, type constructors and type variables allow Haskell to create powerful, flexible, and reusable code through parametric polymorphism. A C++ template is more like a type constructor than a type variable, though there are some key differences in how they behave. Let me explain. Template is a type constructor, and C templates are mechanisms that allow you to define generic types or generic functions that can operate on any type or a set of types. When you write a template, you're essentially creating a blueprint that can be instantiated with specific types when used. This process is similar to a type constructor in Haskell, which takes types as arguments and returns a new concrete type. Example: template as a type constructor. CPP copy coded template less than name t greater than struct box t value. Here, box is a template type constructor that takes a type t and constructs a new type. Box less than greater than. For example, box less than and greater than is a type. Box less than greater than is another type, and so on. The template parameter t is a type variable because it represents an unknown or generic type that will be specified when the template is instantiated. So box less than and greater than, box less than double greater than, box less than c string greater than, etc. are concrete types constructed by applying the box template to different types, much like how a type constructor in Haskell works. Template Templates against type variables. Templates in C templates are type constructors because they create new types when instantiated with specific types. They act as a blueprint or a mold for generating concrete types. Type variables in C, the template parameter like T in the example above is a type variable. It is similar to a type variable in Haskell in that it can stand for any type, and it makes the template generic or polymorphic. So in C, a template is more analogous to a type constructor because it creates types, while the template parameter like T is analogous to a type variable in Haskell as it represents a placeholder for any type. Key differences between templates in C++ and type constructors in Haskell. Templates in C++ allow for type-level programming, and they work with both types and values, since templates can also operate on non-type parameters. Templates generate new types when instantiated, similar to how type constructors in Haskell generate concrete types from type parameters. Haskell type constructors generate new types based on type parameters, but do not have the same kind of generalization for value-level programming as C++ templates. In Haskell, you generally use type constructors to define data types, and these constructors can be polymorphic like maybe A or A. Summary: a C++ template is more like a type constructor because it defines a pattern for creating new types when instantiated. Template parameter, e.g. T, is more like a type variable, as it acts as a placeholder for any specific type that will be provided when the template is used. Thus, C++ templates offer a flexible type-level mechanism that shares similarities with type constructors in Haskell, though they also have their unique features and capabilities.
I guess the difference is that there isn't a name here on C++. So I think the thing that was confusing me is the type variable thing. Because I was confusing type variable value constructor. But it is still kind of confusing because I do think that the type variable, so a type variable is going to be a type, so it means that it can construct a value. But it's not the same as a value constructor, because a value constructor is going to construct a value of the overall type, and a type variable is going to construct a value from the type that is going to be used to initialize that type. So for example, on the maybe thing, like the nothing is a value constructor because it builds the type maybe. So it's a maybe nothing, I think. Actually, it would just be a type maybe. So it would be a value of the type maybe. So it's a value constructor. But A would be a type variable, I think. Yeah, but this, I don't remember if it is like that. But that's how I'm thinking about it right now. So A would be a type variable, which means you could put any type you want there. So it could be a string or an integer or whatever. And that would later on be used to create a value from that type. So it creates a value from one of these types here, but it doesn't create a value from the maybe type. So that's why it's a type variable. So it's used as a placeholder to put a type there, but it doesn't construct a value of the type, the like more general type that is being built. And the value constructor builds a value from that type. I'm gonna ask again. I'm gonna read this first.
Yes, C++ can use templates with multiple type parameters, and you can also use them to create product types, types that combine multiple values, similar to tuples or structs. These features are conceptually similar to Haskell's type constructors that use multiple type variables. Multiple type variables in C++ templates. Just like Haskell allows a type constructor to take multiple type variables, e.g., data pair b equal to pair b, C++ templates can also accept multiple type parameters. Example of a template with multiple type parameters: product type cpp copy coded template less than AB name t1, type name t2 greater than struct pair t1 first, t2 second. In this example, pair is a template type constructor. It takes two type parameters, e1 and t2, making it similar to a product type in Haskell, where you define a type that holds two values of possibly different types. You can then instantiate this template with specific types, creating product types. cpp copy coded pair less than int, double greater than p1, pair where the first element is an int and the second is a double pair less than d, string, char greater than p2, pair where the first element is a string and the second is a char. Product types in C++ using templates. A product type is a data type that combines multiple values into a single type. In Haskell, a product type is defined as a tuple or a record, like data pair b equal to pair b. In C, you can create a similar structure using templates. For example, a pair template as shown above defines a product type that holds two values. Each value can be of a different type, which makes it flexible and reusable, just like Haskell's product types. Example with struct, cpp copy code template less than tp name t1, type name t. This creates a product type that stores two values. cpp pair is a type constructor that takes two type variables, t1 and t2. Instantiation pair less than int, double greater than creates a concrete type that holds an int and a double. Product types against Haskell's algebraic data types. In Haskell, algebraic data types AD such as product types are created using data declarations. For instance, Haskell copy pair b. This is equivalent to the C++ template example we discussed earlier, with pair taking two type parameters, a and b. The key difference is that in Haskell, the product type is more naturally integrated into the type system as part of its algebraic data type system. C++ achieves something similar using templates, though templates are more general and can also be used for value level polymorphism, e.g., creating generic functions. Conclusion: C++ templates can create product types using multiple type parameters, similar to Haskell's algebraic data types. Templates can take multiple type variables, e.g., template less than AP name t1, type name t2 greater than, to create product types, which are similar to Haskell's tuples or record types, data pair b equal to pair b. templates. In C++, provide type-level polymorphism, and you can use them to define complex types that combine multiple different types, much like Haskell's type constructors do. Thus, while the syntax and features of C++ templates and Haskell type constructors differ, the fundamental concept of creating generic product types with multiple type parameters is quite similar. In the Haskell example, Haskell copy-coded data may be equal to nothing, just a. A is a type variable, not a value constructor. It represents a generic type that is being used to parameterize the maybe type. The type variable allows maybe to be used with any type. For example, maybe int, maybe string, and maybe double are all valid instantiations of the maybe type, with a standing for different types in each case. Value constructors are nothing, and just a nothing is a value constructor that represents an empty value of type maybe a. Just a is a value constructor that wraps a value of type a into the maybe type. Thus, a is a type variable that allows maybe to work with different types nothing, and just are value constructors that help create values of type maybe a. How this relates to C++ templates. In C, the maybe example would be analogous to a template that is parameterized by a type. You can create a generic product type like maybe using C++ templates. Object target equal to class db instantiate my. Object target equal to class db instantiate my. Object target equal to class db instantiate my. In the C++ version, T is the template parameter, which acts like the type variable a in Haskell. It allows the maybe type to work with any type mabeless than, greater than, mabeless than, double greater than, etc. There are two constructors for the maybe struct. The default constructor represents the nothing case, i.e. has value is false. Constructor that takes a value represents the just a case, wrapping the value v of type t into the maybe type. The maybe template in C++ is a type constructor, and it is parameterized by the type t, which is analogous to the type variable a in Haskell. Key points: a in Haskell is a type variable, not a value constructor. It defines the type that maybe can hold, nothing, and just are value constructors that create values of the type maybe. A C++ templates can be thought of as type constructors that take type parameters, similar to Haskell's type constructors. The maybe template in C++ would be parameterized by a type t, just as Haskell's maybe a is parameterized by a. To summarize, in Haskell, a is a type variable. In C++ templates, you would use a template parameter like t to define a type constructor. The value constructors like nothing and just are used to create values of the type maybe a in Haskell and mabeless than, greater than in C++.
Yeah, now I understand. So what I was saying is basically correct. According to ChatGPT, obviously, but I do think it is correct. So A is a type constructor, so it's gonna allow you to use any type. And then nothing is a value constructor. And it represents so like value constructor would be like an instance of a class. So it's the class constructor, for example. And the type constructor is more like the type variable is more like the template variable. So it's like a placeholder that is generic that allows you to put any type as long as they are able to do whatever you are asking them to do. And then the type constructor would be the template itself, so it doesn't have a name on C++. But on Haskell, you could put the name. So in the maybe case, that maybe would be the type constructor. I'm gonna ask one more question, then I'm gonna move on to the other stuff. Yeah, so I think I do understand now. It's still gonna be confusing, but it's becoming more clear how it works.
Yes, in the example you provided. Haskell maybe would indeed be a type constructor, but it is a nullary type constructor, meaning it takes no type parameters, i.e. it doesn't take a type variable like a and maybe a. It defines a type that can either be nothing or just, but without any associated values or parameters for the constructors, nothing, and just are value constructors, but in this case, they don't carry any associated data. They are used to create values of the type maybe, but without any type parameters or values wrapped inside. Explanation: maybe is a type that can take one of two forms, nothing representing the absence of a value, just representing the presence of a value, but without any associated value. This is an example of a type with no type parameters and value constructors that represent two possible values of that type. It's essentially a type-level enum with two possible values, but both of them are just tag values without any associated data. Comparison to C++. This would look somewhat like an enum in C, where you can have a type that has a set of predefined values but no associated data. Here's a possible C++ equivalent using an enum. CPP copy code enum maybe nothing just. In this C++ case, maybe is the type like maybe in Haskell. And just are the enumeration values, which are analogous to the value constructors in Haskell. Key points: in Haskell, when declared as data may be equal to nothing just, maybe is still a type constructor, although without type parameters, and nothing and just are value constructors. Equivalent would likely use an enum with values nothing and just as potential values of the maybe type.
So it's still messed up here, but I'm not gonna do this now. I'm more interested on the thing there. I still like I don't understand. It might be because of the errors though. But maybe I should try to put this on a different thing. Let's see. If it's giving the warning, then it means it didn't change the thing. think the other one is notification theme change. So I'm gonna try this one. If neither of these, this one already doesn't work. So if this one doesn't work, I'm probably gonna move this. I'm gonna try to move this stuff to this part. So I call after. But I'm gonna ask now about the serialization. Oops.
Serializing side effects, is it common? In general, serializing side effects is not a common practice in many programming paradigms, particularly those that focus on pure functional programming, where side effects are minimized or avoided altogether. However, there are scenarios in which side effects are inherently tied to the state of a program and need to be captured, saved, or replayed later. This is often done in imperative or stateful programming contexts, and certain software systems explicitly deal with serializing side effects in different forms. Examples of scenarios where serializing side effects might make sense: logging, recording side effects like changes in system state, user actions, or errors into log files for future inspection. Saving the results of expensive computations to a file or a database to avoid repeating them in the future. Serialization. For persistence, saving the state of an application, including its side effects like updated data or external system states, to disk so that it can be resumed at a later time. Fundamental first principles and concepts associated with serializing side effects. State persistence. When side effects affect the state of the system, serializing side effects can involve saving that state so it can be restored later. Persistence refers to the capability of software to save state to disk or some form of external storage for long-term use, idempotence. This concept ensures that an operation can be applied multiple times without changing the result after the first application. In some cases, serializing side effects requires making sure that reapplying an effect doesn't lead to unintended outcomes, which is important in the context of recovery or re-execution after serialization. Replayability. In many cases like caching or logging, the side effect needs to be replayed when needed. This requires capturing enough information to recreate the effect in a reliable way later. Sourcing. A pattern where all state transitions are recorded as a sequence of events, which can be replayed to restore the state of the system. Concurrency and ordering. When side effects occur in a multi-threaded or distributed system, their order and the way they are serialized may need careful management. Atomicity ensures that side effects happen in full or not at all. Transactions are used in databases to serialize side effects and guarantee consistency. Keywords and search terms. Event sourcing. A pattern where state transitions are saved as events which can be replayed, rather than saving just the final state. Serialization. The process of converting an object or state into a format like JSON, XML binary that can be easily saved or transmitted. Idempotence. Making sure that applying the same side effect repeatedly doesn't alter the outcome. Logging. Storing side effects like errors or operations in logs. Persistence. Storing application state to disk or other permanent storage for future use. Caching. Storing the result of expensive operations to avoid repeating them. Transactional memory. A programming model for concurrency that ensures that operations on shared data are executed in a way that avoids conflicts, often with the ability to serialize these operations. Is serializing side effects a sign of a problem? Whether serializing side effects is a problem or a necessary design decision depends on the context. It may be a signal that the code could benefit from some improvements, but in certain cases, serializing side effects may be the correct approach. A sign of potential improvement. If side effects are being serialized excessively, it may indicate that the code is too stateful or not purely functional. This could lead to difficulties in reasoning about the code or maintaining its behavior. In such cases, refactoring the code to minimize side effects or move to a more functional paradigm might be beneficial. By reducing side effects, you make the system more predictable, easier to test, and less error-prone. A necessary design decision. In some contexts, serializing side effects is not only sensible but required. For example, in systems that involve distributed computing, logging, or caching, serializing side effects can help with state recovery, fault tolerance, and performance optimization. Event sourcing is another pattern where capturing and serializing every side effect in the form of events is essential for restoring the system state at any given time. Thoughts on serializing side effects, e.g., caching, saving them on a file. Serializing side effects like caching or saving state to a file is common in many systems, but it must be done carefully to avoid introducing unnecessary complexity or errors. Here are some considerations. Caching results can improve performance by avoiding redundant computations. However, caches can become stale, leading to inconsistent or outdated state if not managed correctly. Considerations like cache invalidation, expiration, and consistency are critical when deciding what to cache and when to invalidate or recompute values. Event sourcing. Storing all state changes as events provides an auditable and reproducible history of the system's behavior. This can be especially useful in distributed systems or systems where the ability to replay events is valuable. However, it can introduce complexity in the form of large data volumes, needing to store and efficiently retrieve a history of events. Persistence and recovery. Serializing side effects to ensure system recovery, e.g., saving user data to a file or database, is often necessary for resilience and reliability. However, this requires managing complex state transitions and ensuring that serialized data can be correctly restored to a consistent state. Transaction management can help ensure that side effects are serialized in a way that maintains system consistency, especially in multi-threaded or distributed systems. Performance against complexity. While caching and persistence can improve performance, they introduce additional complexity in managing serialized state. Considerations like storage overhead, read, write consistency, and the correctness of the saved state become important when serializing side effects. Trade-off between the performance benefits of serializing side effects and the complexity of managing that serialized data should always be considered. Conclusion. Serializing side effects is not inherently bad. In fact, it is often necessary for performance caching, fault tolerance logging, and resilience. Event sourcing. Persistence. When side effects are being serialized excessively or unnecessarily, it may signal that the system is overly stateful or not as functional as it could be. Whether or not to serialize side effects depends on the context and the design goals. While it can be a practical solution, it should be approached carefully, especially regarding state consistency, replayability, and performance optimization. If the need to serialize side effects becomes complicated or difficult to manage, it may be worth considering ways to reduce side effects or adopt more declarative approaches, e.g., functional programming or event sourcing. However, there are many legitimate cases where serializing side effects is an appropriate design choice, especially for systems requiring fault tolerance, state persistence, or performance enhancements.
I should claw. So.
The function you described for creating a tree by adding children to a root node primarily fits into the object-oriented programming OOP paradigm. Explanation. Object-oriented programming OOP. Encapsulation in OOP. Objects are encapsulated units that contain both data attributes and methods functions that operate on the data.class. An object, you typically define a node class that has a children attribute, a collection like a list, array, or vector, and methods to add children to it. Inheritance and polymorphism. While your example is more about composition building up a tree structure, OOP principles are still evident in how objects interact with each other. For your function, CPP code node root equal to new node. Node child on equal to new node. Root greater than add child on. Node child 2 equal to new node. Root greater than add child 2. Node is a class that represents a node in a tree. Add child is a method that belongs to the node class, indicating that the tree structure is encapsulated within the node objects. This approach aligns well with the OOP principles of encapsulation and method call. Procedural programming. While OOP is primarily concerned with objects and their interactions, procedural programming focuses more on steps or procedures. If the function were to operate solely through procedural code, e.g., a set of functions that manipulate node objects without encapsulating them within classes or methods, it would be more aligned with procedural programming. In procedural programming, you might not use add child as a method, but rather write functions that directly manipulate node objects. Functional programming. Functional programming focuses on functions and their composition, immutability, and side effect-free computations. Function you described does involve side effects modifying the state of root by adding children, which makes it less compatible with functional programming. In a functional paradigm, you might use recursion or higher order functions to construct the tree, avoiding mutable state and in-place modifications. Classification on the procedural OOP functional spectrum. OOP. This function fits into the OOP paradigm because it is centered around objects nodes that interact with methods add child. The state is encapsulated within objects, and operations are performed on the object's methods. Procedural. If you were writing individual procedural functions that don't encapsulate the state in objects, e.g., functions like create node, add child, get children that operate on node instances, it would lean more towards procedural programming. Functional. The function doesn't fit well into the functional paradigm because it involves mutable state and side effects, adding children to nodes, which is against the functional programming principles. Conclusion. Your function of creating a tree by adding children to a root node is best classified under the OOP paradigm. It makes use of encapsulation, method calls, and object interactions, which are core principles of OOP. While it can be described using procedural code and involves some elements of procedural programming, it still encapsulates behavior and data within objects, aligning it more closely with OOP. The function you described fits primarily within the procedural programming paradigm. Here's why. Procedural programming. Nature. Procedural programming focuses on a sequence of actions or procedures to be performed. It emphasizes algorithms, using functions or procedures to perform tasks. The organization of code is often by functions that operate on data, rather than by data itself. Example, the function you described, root greater than agile child 1, root greater than agile child 2, etc., operates on a series of objects nodes and directly manipulates them by connecting them. This is a procedural approach because it involves a sequence of instructions and control flow based on the specific task required, e.g. adding children to a root node. Object-oriented programming, OOP. Nature, OOP is based on objects which encapsulate data and behaviors. It revolves around the concepts of classes, inheritance, polymorphism, and abstraction. In OOP, you would typically see a method like agile defined within the node class, which would encapsulate the logic for adding a child node in. This context, while OOP can involve adding children to nodes, e.g. using methods on a node class, your approach doesn't take full advantage of OOP principles like encapsulation and polymorphism. Instead, it focuses on procedure and control flow. Functional programming. Nature. Functional programming emphasizes immutability, pure functions, and avoiding side effects. Functions in functional programming should not change the state of objects, but rather return new objects or values based on the input. Not a perfect fit. The approach described doesn't align well with functional programming because it involves mutable state, adding children to a root node, and side effects modifying the root node's children list. In functional programming, you might create a new tree or a new node without altering existing state. Classifying the function. Procedural spectrum. The function fits well within the procedural spectrum because it describes a series of actions to be performed on a data structured node. It focuses on how data is processed and controlled, e.g. connecting nodes in a tree. OOP. Elements, although not fully object-oriented, it does involve objects nodes and the use of methods to manipulate those objects, which could be seen as aligning with some principles of OOP. Functional elements. There are no inherent functional programming elements like immutability or pure functions. The function explicitly manipulates data, which is not a typical functional programming style. In summary, this function fits best within the procedural programming paradigm, specifically focusing on data manipulation and control flow, which is characteristic of procedural programming approaches rather than purely object-oriented or functional programming paradigms.
I'm gonna put with these keywords because then it's probably gonna recognize that is Godot, but I don't think that matters that much.
To address your situation in which a derived class foo is initialized with a vector myvector that is not being serialized because it is passed from an external function, we need to focus on how serialization works and how you can ensure that all relevant state, including the effects of myvector, gets serialized. Key concepts: serialization of class state. When serializing objects, the process typically involves writing the data members of the object to a file or another medium. If myvector is an external state that is not part of the class's internal data members, it won't be included in the serialization process by default. Modifying the class to include all relevant state to ensure that myvector is serialized along with the internal state of foo. You have a couple of options. Store the vector internally. One approach would be to store the vector as part of the class's internal state. For example, cpp copy code class foo, public node vector list string name greater than myvector, public foo const vector list string name greater than vector, myvector vector constructor logic. Now myvector is an internal data member of foo, and when you serialize foo, you can include myvector as part of the state.ed, a serialization method. If you can't store the vector internally, perhaps for design reasons, you could add a method to the class that explicitly serializes the external state. For instance, a method like serialize external state could take care of writing the state of the external vector to the file. You would call this method explicitly in your serialization code after constructing the object. Example: cpp key code class foo, public node public void serialize external state vector list string name greater than vector. Serialize the external vector to the file. In your serialization code, you would then call this method after instantiating the object. cpp copy code foo my foo equal to menu foo my foo greater than serialize external state my vector. Monads and side effect serialization. Monads can help structure side effects like serialization, but they're not a direct fit for serializing external state like my vector. However, they can help manage the flow of side effects in a more predictable way, especially when you need to maintain a sequence of actions that involve external resources or mutable state. Monads in Haskell are often used to sequence operations while encapsulating side effects like IO state and exception handling. For instance, the state monad can be used to manage state changes over time, and the IO monad can encapsulate operations like reading from or writing to files in. See, there isn't a built-in monad type like in Haskell, but you could implement something similar to manage side effects, e.g., a custom monad-like structure for serializing state. Managing side effects in this context. Side effects refer to the changes in state like modifying foo or serializing its state. When dealing with side effects, it's important to ensure that all changes are captured and serialized. This means making sure that every state change that should be persistent, like modifications from the vector, is explicitly tracked and serialized, either through internal state or through explicit serialization calls. What you should do: Option 1, internalize the state. The easiest and most natural way to solve this is to make sure that the state passed to the constructor myvector is part of the class's internal state, which is then automatically serialized. This fits well with object-oriented principles and ensures that all state is captured consistently. Option 2, explicit serialization. If you don't want to store the vector internally, you can explicitly serialize the external vector by adding a method to your class that accepts external state like the vector and serializes it. Monads and side effect serialization. Monads aren't necessary for this problem in C, but they are useful in managing complex flows of state and side effects, especially if you have more complex serialization needs, like maintaining a sequence of operations on the object or handling errors in the process. A more monadic approach might involve creating a state monad-like structure to manage the transformations on the object and its external state in a more declarative way, but this is over-engineered for your example. In C, simple approaches like the two options above will be sufficient and more idiomatic. If you don't want to change the structure of the class just for serializing state, and you still need to capture or serialize the impact of external side effects like modifications made by the vector passed to the constructor, without modifying the class, there are still several strategies you can explore. These strategies involve separating the concerns of state management, serialization, and external interactions while adhering to good design principles. First, principles involved. To understand the fundamental principles at play in this situation, let's break it down. Separation of concerns. The class is responsible for maintaining its state, but external interactions, e.g. modifying state via constructor or external vector, should be handled separately. Serialization can be seen as an external concern that needs to observe the state changes, but you don't want to interfere with the class design.state. Persistence and serialization. Serialization is about capturing the current state of an object and storing it for later use. A class may have state that is not naturally persisted within it, e.g. external vectors, but this state can still be captured during serialization. Immutability and side effects. When external side effects change the state of an object, the key is to track how those side effects affect the object's internal state. While you can't always control the side effects directly, you can track them externally and then apply the changes during the serialization process without reflection. Some systems allow you to inspect an object state dynamically, e.g. by reflection or introspection. This can be helpful for serializing objects whose state is indirectly modified by external factors. Possible strategies. 1. External serialization framework. Create a separate external framework or helper function responsible for serializing objects and their external state. This framework can capture external changes and handle the serialization without modifying the class itself. Observer pattern. The external state, the vector, can notify an observer whenever it changes. The observer can then serialize the change to the class state, ensuring that external side effects are captured. The observer could also be responsible for maintaining a list of changes to be serialized. Example: CPP copy code class foo, public node, internal state public, void apply external state const vector list and string name greater than, my vector, apply the state externally but don't store it internally, can affect internal state indirectly. Class foo serializer public, static void serialize foo, const vector list and string name greater than and external state, serialize internal state, serialize the effect of external state on foo greater than, apply external state, serialize external state as needed. Here, foo serializer knows about how external state affects foo, but does not alter the foo class itself. 2. State snapshots or delta serialization. You could implement a system that tracks changes to the state of the object, either through a logging mechanism or a delta mechanism. For example, using a snapshot or diff approach, you could serialize the changes between object states after they've been modified by external effects. Snapshot pattern. A snapshot is essentially a full or incremental capture of the state of an object at a certain point in time. When external modifications happen, the changes can be captured by a snapshot manager without modifying the object directly. Delta serialization. Track only the difference delta between the object state before and after changes, including external side effects. For example, CPP copy code class state tracker. Track changes in object state, possibly using delta's public. Void capture delta const foo, const vector list and string name greater than and external state. Object target object equal to class db instantiate. My Introduce serialization hooks that manually trigger the serialization of state, including the external changes. These hooks could be separate functions or classes that modify the serialization process, adding the effects of external side effects without altering the object structure. Example: CPP copy code class foo, state, class foo serializer. By invoking the serialize function with both foo and my vector, you manually control how the state of the object is serialized, including the external side effects. 4. Using a serialization proxy. A proxy can act as an intermediary between the object and the serialization process. The proxy would represent the state of the object, including changes caused by external side effects, and be responsible for the serialization process. The proxy could maintain references to the original object and its external state, and apply the effects when needed. Example: CPP copy code class foo, object target object equal to class db instantiate. My Keywords and search terms. To explore more about capturing or serializing external side effects in an object, these keywords and search terms would be helpful. External state serialization, side effect tracking, state persistence, observer pattern serialization, delta serialization, snapshot pattern, proxy pattern for serialization, serialization, hook state tracking mechanism, object serialization without changing class. Final thoughts. To avoid changing the internal structure of the class while still capturing external side effects, you can implement auxiliary components such as proxy serializers or external state trackers that are responsible for handling the serialization process. These components ensure that the external side effects like the vector passed to the constructor are correctly serialized without modifying the class's structure. This maintains a clean separation of concerns and allows for flexibility in managing serialization in a way that doesn't disrupt the class design.
Yeah, none of these options that they gave make a lot of sense for me. Yeah, so there is something wrong still because of it's not showing the buttons. So it might be because of the minimum size. But I think that's now is working with the other stuff. But maybe it doesn't have anything actually. Because if it was the minimum size, it wouldn't be showing the thing here. It might be the minimum size of the buttons. The problem is that I can't see it here because of the way that I designed there. In order to be able to see it on the editor, you have to create the thing outside and then add to the thing. And if I create inside of the class, then it adds the node twice. So that's the problem. Or you can make them as properties. You can make them as a property of the class. I can make the vector that I have the buttons there as a property, and then subscribe the property using add property, and then it's gonna show here. So I'm not really sure why, but I think it doesn't matter that much because it's not gonna be that hard, I think, to solve, hopefully. It looks like the answers ChatGPT gave are the answers that I talked about before, that I already knew. And the other keywords that it gave me is also seemed that it doesn't make a lot of sense. And like the solution that it gave me there, like it isn't what I was looking for, because what I'm looking for is more of a systematic way to deal with the issue. And all those solutions are related to the specific class that I want to say. But thinking more about this, it is becoming a lot more clear what exactly is the problem. And it comes down to serializing side effects. So like you have the internal state of the class, and the serialization is bounded by this. So it's like when you're saving to the sync file, you're basically snapshotting the state of the class by using Godot's classes. So use variants Actually, don't put. There's the class DB bind method for the functions. Then add property. Add signal. And this is done through the variants. So it's basically, I think that this determines the scope of what's captured by the sing files, and is capturing the internal states of the classes. So anything that I do outside to change the internal state of the class is not captured on the sing file, which means I lose. So this is not a problem if you are running the game at the same, like if I incorporated the code that I have there as part of the engine in the same way that they initialize the editor, which is essentially just like encapsulating everything on the same node, and then like connecting the implementing side effects inside of a constructor of another node. Then if you do that, then you can, it is not a problem that you have side effects, because the moment that the editor initializes the scene is going to run the constructor again. And the moment that the application initializes the scene is going to run the constructor of the class, and because it runs the constructor of the class, it's going to run the side effects. But the way that I'm doing now, I run the function once, then the function has the side effects, but it's not a part of the scene. So the side effects are not captured, which means that the final state of the scene is going to be reduced to the internal states of the classes. So that's the fundamental problem. That's what it comes down to. And this is directly correlated with the mechanism we use, because this is a bridge between the state outside of runtime and the state that is serialized. So like this is like a bridge of information which works through types. Which is very interesting. So the reason why it's not a good idea to put everything inside of one class, one node, is because the way that the editor exposes the nodes. So the editor is going to expose based on the whatever nodes have as an owner. So like if you put them inside of the constructor and you add them you add the owner as the node that is being constructed. So for example, let's say the editor node is the main node that creates the scene, and then inside of the editor node constructor you create another node called foo. What's gonna happen, I think, based on the other times that I was trying to do stuff related, is that the constructor is gonna run twice, I think. So it's gonna try to create the foo class twice. If you set the foo the owner as the editor node, because that means that indicates to the system, the serialization system, that is supposed to save this class here to the scene. But I think it's gonna run twice, if I remember correctly. But I'm not 100% sure. Maybe I could try that to see what happens. Because it might be just because of the way that I was trying to save the scene before. So if this did work, and I could add nodes separately inside of a constructor of another node, then obviously instead of creating a function, I could just create a class. The only purpose would be to have the connection of the other nodes as a constructor, and then they would show on the editor, because they would be shown. They would show as children of the root. The problem is, I think that the editor creates the node twice when you put them inside of the constructor, and it only doesn't do that when you don't set the owner, because that means that it's not gonna save them to the thing. Yeah, I think that's the problem. Like, it's gonna save the node twice, because it's gonna save one time because you set the owner. So it's like it's gonna let go to a node that is a separate thing, but then when it's saving these nodes, when it's like loading the scene from the cache state, It's gonna run the constructor, and then it's gonna initialize this node, and then it's gonna try to initialize the same node again, and then it's gonna fail. I think that's what happens. And if you don't set as the owner, then you're not gonna have access on the editor because you're not gonna be able to see the node on the scene, which is the stuff that I had there just now with the buttons. I can change the buttons on the editor because I'm not subscribing them here as a property of this class, and I'm not exposing them. I'm adding them as children of these nodes, and I'm using the normal function, which it doesn't set the owner of the thing. So the easiest way to task would be to, but I think it would be better to create another class but I think I'm pretty sure that I already tried this. I'm not really sure if it's worth trying again. 'Cause if it was possible to set the owner inside of the constructor, then instead of having the function that I'm using, because I'm using functions to create the scenes, so instead of having this function, I would have a class that is the IDE layout class. And then inside the constructor, I would put essentially the same code. And then the scene would be the class. That would be a lot easier because it would allow me to capture the side effects inside of the constructor of the class. It's like is carrying over the state. So I guess the question is the constructor. So maybe that's the answer. So maybe I have to see how does Godot reconstruct the classes? And I'm pretty sure I already seen this. And so this is gonna be on the load scene, I think, on the editor node. Oh, there is I remember seeing, and it's gonna use the class DB, but I don't remember exactly where. So maybe the key to this is on the package scene. So if I could change the package scene to so first I have to clarify how they reconstruct. Because obviously if they are running the constructor of the class, then like I can use the same mechanism to get the state. And then I just have to transfer that into something else or into a function that I can use. Maybe like something on the package scene. So maybe I can put a callback function on the package scene or something. Like can put a callback a function pointer, but the problem is like I'm not really sure if it would work because you would have to be like it's not the same thing. So clarify how they use class DB. This is gonna go into the because I already know like it's gonna go into this stuff here. So they're basically using the variant and the bind methods, and they're using all those templated classes to do this. That's how they're able to convert the information again. So the key is the classes, and that's the problem, I think. So the reason why I assume that they did like this is because constructing the type system should be able to convert the information when it comes to side effects is going to be very complex. Very interesting. Yeah, but I guess the question, there should be a way, I think. Because if I could just I guess I need to spend more time to see how they do this. If I could transfer the same logic to run the constructor, but instead of running the constructor of a class, I just run whatever function I want, then obviously I would be able to encapsulate side effects. Because basically the same thing. And then if I did this, then it would be a lot easier because then I can I can separate the logic from the classes into the taking, like, I can create just stuff outside and then change the state. But I'm not really sure. This is the reason why I asked there, ChatGPT, which is still not very clear to me. Because the fact that I want to do this might be an indication that it's not the right thing to do. Because maybe I should be minimizing the side effects, so I should change the structure of the class. So in this case, this example that I have here, it would mean that is more correct to make the vectors parts as a member variable of the class instead of, and then making the things. And it might be the case that is always like this. So like whenever you have a side effect that you want to implement, I think the only thing that would be different would be the signals, because signals are inherently outside, but signals are easy to cache because of the variable, the flag there. So it's both signals and there was something else as well. Yeah, signals and the connections of the nodes. And those are the two main things. Yeah, but the connections of the nodes is already working, so it doesn't matter that much. So it might be the case that I should change the structure of the class and then expose the stuff on the editor. Every time that I have something like this, where I want to put like something outside to change the behavior of the class, I should be just changing the structure instead. But the question, and I'm not really sure how to clarify that, is if from first principles perspective, if this is always going to be the case or not. And I think it's very hard to know. So I'm gonna see. I'm gonna think. Do you think? Fields.
When developing an object-oriented programming OOP paradigm, particularly for something like building a scene tree in a game engine such as Godot, minimizing side effects is generally a good practice, but it should be approached thoughtfully and contextually. Why minimize side effects in OOP? Predictability and maintainability. OOP encourages encapsulation, where an object's internal state is protected from external modification. Minimizing side effects helps preserve this encapsulation and makes the system more predictable. If a function or method has side effects, it can modify global or shared state, leading to difficult to debug behaviors or unintended consequences. Game engine, particularly one that handles complex scene graphs or trees, needs to be predictable because the logic for updating and rendering the scene should be as deterministic as possible. Unchecked side effects can cause inconsistent behavior in different parts of the system, making the engine hard to maintain or extend. Testability fewer. Side effects make objects and methods easier to test. If methods have side effects, tests might become more difficult because they depend on external or mutable states that are hard to isolate. Keeping side effects to a minimum means that a test for a class or function will be more focused on the input-output relationship relationship, making it easier to write meaningful tests. Concurrency in a game engine, performance often relies on being able to handle concurrent or parallel tasks, e.g., rendering, physics simulation, AI. Side effects, especially if they mutate shared state, can cause race conditions or other concurrency issues. By minimizing side effects, the system can be more easily made thread safe and performant. Reusability: if your objects are designed with minimal side effects, they are easier to reuse across different parts of the engine or even in different projects. A class or method with a large number of side effects might be tightly coupled with specific scenarios, reducing its general utility. Is minimizing side effects always the best approach in OOP? That being said, minimizing side effects is a guideline, not a strict rule. There are times when side effects are necessary and appropriate. Efficient scene management in game engines. Building a scene tree requires updating and manipulating the hierarchy of objects. This inherently involves side effects modifying the structure of the tree, but it's not a bad thing because the side effects are part of the expected behavior of the system. For example, when you add a child node to a parent in a scene graph, the side effect, the actual modification of the tree structure, is part of the logic that is expected. The key is managing these side effects in a controlled manner so that other parts of the system, e.g., rendering, physics, input, aren't unexpectedly affected by changes in the tree.state. Changes are sometimes inevitable. In an OOP system, objects must sometimes change their state. For example, a transform object in a scene may need to update its position based on user input or physics simulation. This update would technically be a side effect, but it's part of the object's expected behavior. Challenge is ensuring that these changes are localized to the relevant objects and do not lead to unintentional modifications in other parts of the system. Not event-driven programming. In game engines like Godot, the event-driven nature of things such as user input, collisions, or timers means that side effects are part of the system's natural flow. For instance, events like mouse clicks or collision detection will trigger side effects, like changing the state of objects or activating animations. While these are side effects, they are essential to the game's behavior. The key here is to control when and where side effects occur, ensuring that they don't propagate in unintended ways. How to manage side effects in an OOP context like a scene tree. Encapsulation keeps side effects as local as possible. For example, when manipulating a scene tree, the changes to the tree should be encapsulated within methods like add, remove, etc., so the changes don't affect other unrelated parts of the system. This encapsulation ensures that other parts of the engine are insulated from unintended modifications to the scene tree.event. Handling and delegation. Use events or delegates, e.g., signals in Godot, to communicate changes in state to other parts of the engine. This allows different parts of the system to react to side effects in a controlled manner without direct dependencies. Immutability. Where possible, if it fits your design, you can consider immutability in parts of the game engine. For example, using immutable data structures for the scene graph or transformations would mean that instead of modifying the objects directly, you would create new objects representing the updated state. This avoids changing state in place, reducing side effects. Functional techniques. Incorporating functional programming techniques into the design of your system can help reduce unintentional side effects. For example, representing certain game objects or operations as pure functions that return new states rather than modifying existing states can help make the system more predictable. Explicit. State management. Use a state manager or system like the entity component system or ECS to keep track of changes in state. In such systems, the side effects, like changing position, health, or other attributes, are managed in a centralized way, making the flow of side effects more predictable and controllable. Conclusion. While side effects are inherent in many game engine operations like scene tree management, their impact should be controlled. In OOP, minimizing side effects when possible is a good practice for maintainability, testability, and performance, but it's not always practical or desirable to eliminate them completely. The key is to ensure that side effects are well managed, localized, and predictable within the context of the engine's needs. In a game engine like Godot, for example, side effects will be a natural part of the scene graph system, e.g., adding or removing nodes, but you can manage how these side effects propagate through the system. A well-structured OOP design should focus on reducing unnecessary side effects while acknowledging that some side effects are essential for the functionality of the system.
I want to see why. This is the last thing that I'm gonna do. I want to put a breakpoint here. I want to see why it's not showing the icons there. It might be because of the difference in the way that the theme icon works and the way that the resource loader works when it comes to the size. It seems that it's not even calling the function. If it was because of the event never gets executed, then it wouldn't give the warning on the other times. So I think that the easiest solution to this is to separate there. I'm pretty sure this is not gonna be that hard. I think unless there is an unexpected thing, unexpected problem. I think that's it's not gonna be that hard to solve this. I can separate the parts that I am putting the icons on the button, basically creating a button, and the parts that I'm adding as a child, and the other element as a child of the other one. Yeah, I think that's they don't have to be on the same place because I can do it based on the name. It would be better if I could do it on the same place, but I don't think it's necessary. So I'm gonna have to think about it, and that's why. So it's not finding this. Now the problem is obviously if I put this stuff here, then I think it's gonna complain as well, or not gonna complain, but it's not gonna have the content scroll container when I call the function. And if I put this one on the other one, then I think it complains as well. I'm gonna go back to the way that it was before and see the message. I'm gonna put a warning here as well later. So put else condition here and then put the warning. Yeah, so the easiest solution is gonna be to figure out how to split this into different parts. And I'm gonna change this. I have to spend I'm gonna spend more time thinking about it. So I'm gonna stop streaming now because this is related to the whole thing about the side effects and this stuff, but I'm probably going to so the conclusion that I have so far is that it's very likely that if you want to serialize the side effects on the situation that I have here, is probably an indication that you should try to change the class instead. So it's probably an indication that what you're doing is not very good if you have side effects outside of the classes. With the only exception being the adding different nodes to each other and the signals. And I think outside of those two is probably, but I think it goes deeper because the engine is done on the object-oriented paradigm. So that's the reason why this is the case, which is not always going to be the case, I think. So like, I think an optimal engine would be more, it depends on the use case, obviously, but I do think that the more data you have, the more likely it is gonna be the project is going to be to use a different approach. But then the regardless of which approach you take, is going to impact the relationship between the code and the way that you serialize the code. So the classes that work on serialization are going to be built to work as type translators. And they are the things that allow you to hold the state. So like it's an information flow, let's say. Because what is happening is that you have two different runtimes and you are bridging the gap between them. You're transferring the state between them through the type system that the language has, because that's what is going to allow you to capture whatever is running. And the the complexity is going to come from the side effects and the mutability. So the more immutable and less side effects you have, the easier it is to capture the state, because it's like you have everything on a box, so it's less volatile. So I would assume that if you want to serialize functional programming, it's a lot easier than if you want to serialize procedural programming, because procedural is more volatile. So I think that's the main takeaway that I'm getting from this. And for my specific case there, because of C++ and because of the Godot's design, you're much more incentivized to create to encapsulate everything inside of classes. So if you have something that is a side effect, it's very likely that it's not very good. But it's not very good in the context of Godot, which is the thing that is kind of annoying, because it might be the case that for the thing that you're trying to do, the whole paradigm is wrong, and it means that you should change everything basically. So you should change the engine. So like for example, there's the Godax version of Godot, which implements entity component system, and that is a version that is more composition based than Godot, which is object oriented programming. So it might be the case for application you have to change the whole paradigm of the engine, which would mean that it might make it easier to. I think it would still be hard, but the difference would be on the classes that the connection of the classes and the classes that work as the translators between the state of at runtime and the state on the disk. Yeah, so the complexity of the framework is directly correlated with the complexity of the type system you need to have to convert the state from runtime to disk and then from disk to runtime. And the question to ask is whether or not this is important enough for me to want to change everything. But I think that's not gonna be like I'm gonna have to compromise and just do like, because building the scene is obviously more important and building projects is more important. But then maybe later on I'll go back and then try to change the engine slightly or incrementally, so that it is more like it can encapsulate the range of the paradigms that has to be directly correlated with the project you're doing. But for the stuff that I'm doing right now, probably what I'm gonna do is to do the stuff that I was saying. So I'm probably gonna put a vector here. Like I'm gonna make this function accept a vector. Or actually, I'm not gonna make it accept the vector. I'm gonna make the constructor accept the vector. Then the thing that I don't like is that it has to be a vector of variance. So I'm gonna try to think about if using a dictionary is better, or if I can use another thing that variance supports. This has to be a type that the variant class has, because that's going to be the class that is used to serialize this stuff using the macros, the add property macro. So basically, the way that I did, you just search for add property, and the problem is that there isn't but I think that you can use vector of string names, if I remember. I'm pretty sure that you can use vector of variance. I'm almost 100% sure. I am 100% sure because I did on the signal. And there is vector of string names here somewhere. Yeah, here. But I don't think I couldn't find on the property. So the first argument you need to pass on the property is the type here. And I guess I can find here. So here there isn't a vector of, but it might be on these things here. Packet. Yeah, maybe is this, but this is array. So maybe I can use this packet string array. But there isn't a type for vector, I think. Because these ones are the vectors that are used to the calculations of position and stuff like that. It's not the vector that only has the templates like different classes. These ones are structs, and I think the vector is a class. So even though it supports there on the variant, it doesn't support on the type here. So obviously one thing that I could do is just try to extend the type, but it's like I said before, it's very annoying, and I don't think it's worth the time to like add another thing here. So I have to compromise and select one of these if I want to do the way this way. Should probably is the way to do it. So select one of these types here. Then you make a variable inside of the class of one of the types. Then you create a side effect outside of the function to determine what icon names you want, which is going to be the vector. Like in this case, I'm thinking about vector string names, but would be a vector variance. And from the constructor, I set the value of the variable, the class, to the member variable should be the side effect that is created outside. And then because I set that value, it's going to cache that value because it's caching with the add property. It's serializing the scene file with that property. Then I use that member variable and the other function to loop over, and then I do the logic based on that instead of looping over the folder. Then from that name, I do the thing here, or the icon. And then I'm probably going to separate the place that I use the content scroll container, because I was just putting here for convenience, but I can do this later, I think. Yeah, because the buttons, they are not like directly correlated. They are just correlated based on the callback function. But when you create it, it's not directly correlated. So I can put, the only part actually is this one, but I think that this one is just for putting on the cache. This dictionary here. And this is the part that I added here to make it easier. But I can put these parts on the other spots there. Because it's basically the same thing. You just have to access this target object through the dictionary instead if I do it outside. So basically loop over the dictionary, then for each one I call. I think that's the reason why I move here, because it's just simpler to think about. But that probably gonna have to try to do it outside. So I'm gonna move this to the other part and then see if it works. But I'm gonna think about the vector first, because I'm probably gonna change that first. So instead of looping over here, I'm going to loop over the variable, member variable, and I'm gonna initialize the variable on the. Just have to think about the type. What type do I want to? Know that these ones are like they are the array and stuff. It's basically a type def, I think. Yeah, I'm gonna stop streaming now. I'm gonna think about this off stream. So probably next time, if I don't solve this offstring, next time I'm going to continue to solve this. And if I do solve this offstring, then what I'm going to do is continue to optimize the class there. So the files, the main thing that I want to do, I just stopped doing this to solve this stuff before continuing to solve the memory leak. But once I finish the memory leak, then I'm going to continue to study the other projects that's implement file system optimizations. And then I'm going to create this class here, or finish this class, which is gonna be basically like a middleman between the model, which is the editor file system class, that I'm gonna change. So that's like I'm gonna try to simplify this, and the fs view, which is the file system doc, which is the front end. So the class that I'm creating is gonna communicate both of them, and I'm gonna make it based on signals instead, I think. Then I'm gonna probably remove the threads for scanning changes. I'm gonna remove as many things as possible, and then I'm gonna add back stuff that I think is necessary. So probably gonna remove everything from here, and then I'm just gonna create other functions, and I'm going to make it based on the events, based on signals. So like this class here is gonna send a signal to this one, then this one is gonna send a signal to this one, and then it's gonna incrementally load the directories based on the time that it takes, and I'm gonna calculate that on the functions, I think. But I'm gonna look into the projects to see how they did it, and then try to translate from these projects here into the Godot stuff. So see you next time.